Today, we have the pleasure of having Mr. Ajay Sharma with us, an experienced research fellow with a robust background in the domains of higher education and academia. Mr. Ajay is particularly skilled in biomedical image processing, machine learning, algorithms, bioinformatics, data science, anthropology, and international relations. His work has been widely recognized and presented at various international conferences, making significant contributions to these fields. Mr. Ajay currently holds the position of Senior Tech Mentor at UpGrad Campus located at Lovely Professional University, where his responsibilities include coordinating and supervising data science students for the Mentor Mind program on machine learning and business analytics solutions. He also teaches various courses such as machine learning, Python for machine learning, and supervises machine learning projects for final year students during the summer semester of 2024. Please join me in welcoming Mr. Ajay Sharma as he leads us through these insightful sessions.
Okay, thank you, Ishika, for this introductory part. Little bit of corrections. It's anthropology. Actually, it's anthropology. The subjective domain is anthropology.
Okay,
So,
sir.
yes,
Go
yes, yes. Anthropology. So, sir, shall we start?
Yes, sir.
Okay, okay, no issues, sir, no issues. Okay, so I'm sharing my screen and just wait for. Uh, just I need just one confirmation that I'm audible and my screen is visible or not. Just one confirmation. Okay, okay. Thank you very much. So here is my presentations and uh, uh, Abhishek sir, just let me know if there is some internet lag. I'm available over here also, so I'm just keep the check over there on my mobile if there
Okay,
is
sir.
some. Okay, so yes. So today we are assembled over here to talk about generative AI and my topic of uh, delivery is today's generative AI concept, application, and implications. So content of my presentation includes introduction, AI, deep learning, generative AI. Then we are going to discuss about few algorithms related with the variational autoencoders, then generative AI, transform-based model, autoencoders, Markov model, CNN, LSTM, and RNN, and then conclusions. So if we will go with the history of AI ML, then it's a vast. If you track the history of machine learning, then we will start from World War II. There is the Enigma machines. Then we have this is used to decipher uh, all the text which is sent by the German forces, and then we have this to decipher those one. We have one another machines, we have Bombay machines. So it's a little bit of history. So if we talk about artificial intelligence, then it's a long story. Okay, so if we talk about 1950, the perceptron model is developed, which we talk about a single layer perceptron model. Then we have adenine, then we XOR problem, which we're dealing with the multi-layer perceptron model, which are, because we have a lot of data inputs are there. So it's XOR problems. Then we have when there is a dark age, because we will go into the world is into the into this uh, recession. Okay, so we have a then we have this cold war is there, so it's called as dark ages. Then we have a little bit science has progressed its own way. We have seen that advancement in multi-layer perceptron model also, which is called as back propagations, again developed by Jeffrey Hinton, the pioneer of engineering in domain of deep learning. Then we have seen advancement in SPM. Then we have deep neural network, and then we have a so this is again 1974, then 1842, 1847, 1960, 52. What will happen? Then we have seen over here that author Samuel, who has coined this term, machine learnings. He has used this IBM and this all sort of things will be happening at that time. Then we have medallions. Okay, then we have this 2016. Then again, as there is a rise of technology, we have a lot of data. Then rise of social media, we will see that a huge amount of data is there, and then we these algorithms will be developed over the times, and then we have a AlphaGo, then we have AlphaFold one also. This is one of the pioneer problem related to the proteins predictions. Basically, to predict the structure of protein is again a challenging task in computational biology. So it has solved by this deep mind division by the Google, and then we have a followed by the generative AI, and then we have a large language model over here. And we today uh, we are just learning about this generative AI. So it's again history we will track, and then we have a detail over here also. 1903, what will happen? So I highlighted the 1951, what will happen? Then we have 1952. So author Samuel who has coined this term machine learnings, and we have a let me take pen also. Okay, so generally over here BTech students are there, final year students are there. Okay, so they are dealing with the machine learning. Even they don't know. So it's very important to trace out of the history from where we have reached till now. So author Samuel is one of the person who have coined this term. Then we have this seed deep neural network, basic of continuous back neighbor algorithms, KNN. Then we have a recognition of image recognitions. So see, if you will see, then these are the over there, but we don't have a data. We don't have a, resources to capture. If we have small things, just like as cameras, so we are capturing this. Here we are storing this in albums. But as 2016, as the internet has penetrated, we have seen that huge rise of data is there. Then we have social media. So the algorithms, now these algorithms will come in, and then we have a rise of this NVIDIA also, the GPU based technology that is using the parallel computing, and we have data, and then we are dealing with these algorithms. Then this uh, 1985 Avitas, what are the identical 8066 backpropagation, Boltzmann machine are there, handwritten digit, support vector machines, one of the most powerful algorithms used for the classification of data. And then we have random forest, again, the one of the most significant algorithm we have. Then we have LSTM is there, long short-term memories. So from here, we will see that we will, yeah, it has started, but yes, little bit. The algorithms are started. Then we have again Gary Korsov, first computer beat this thing. Okay, so computer beat this ImageNet is there. AlexNet comes 2022. Then we have a generative AI. So over here we will see that there is a rise of technologies, and we have an introduction of these algorithms. Gen. Then we have deepface, chatbot. 2019 we have seen the huge advancement related to the deep learning, and it's basically by the deep mind related to the 3D protein structure predictions for sequence is obtained from these animals or the resources. Then we are going to predict the structure of this 3D. Then we have now everybody is talking about this ChatGPT, DALE, and this Chat Gemini. So now we have a these 2024 we have this scene. Now we have a scene of ChatGPT also 4.0, which is dealing with the images also. So this is a little bit of then here history. If you will see, then it's used in almost every domain: neuroscience, cognitive sciences, and structural information, machine learning, robotics, NLP, and image processing. So depending on your area of expertise, we can get our insight into it, and then we will use machine learning, AI, ML, deep learning according to our need. And the history is John McCarthy, and then we have this. So little bit of history part which I have added over here. Later we have talked about Alan Turing. Okay, notions of machines, as the term has been coined by this author in 1952, and then we have a John McCarthy who has this author Samuel has also done machine learning, and he has coined the term AI. And then we have the Alan Turing machines. So this is a little. Then we have a complexity zoo. Okay, so these things are interlinked with one another. All the things are interlinked, just like the AI, ML. Then we have over here we are dealing with the regressions. And in the regression is again further divided into linear. Then we have logistic. Then we have multivariate clustering problem, K-means, and then we have hierarchical clustering also. So this is a set of AI and ML. Then we have this deep learning algorithms also, which are here. So today we are going to learn few hands on this session on the CNN also, LSTM also, RNN also. Then we have a gens also, autoencoder also, and then we have a big data. The data which contain these properties comes under the properties of this category of big data. So if we are dealing with data, then we have the data which contain these properties: volume, veracity, variability. We can say this is comes under the big data. Otherwise, no, there should be no. So generally, we will ask few question over here that what is the big data, and some of the students or some of the fellow mates will get confused. But yes, big data. So if the your data sets which you are dealing with the machine learning AI, if this contain these properties, then we can consider that that data is called as a big data. Otherwise, it's not a big data. Then we have data science domain also, which dealing with the mathematics, statistics. Then we are going to data visualizations. Over here we have exploratory data analysis. So stat part is used by this big data to analyze big data. And when we are going to repetitive tasks, it comes under the machine learnings. And then we are providing the features. This will come under machine learning. If it will do automatically, then it will come deep learning. And when it will suggest something also, then it's come large language model also, or it's a generative AI. It is giving us some kind of suggestions also. So there is a little bit of difference, and hierarchy will go from AI to ML to DL to generative AI. And then we have LLM also, large language models. So in this way, our hierarchy will goes with respect to in with respect to evolution in technology. So this is then we have dealing with the generative AI. So it's a generative AI variational encoder. Then we have vector quantized generative adversarial network also, GANs also theirs. So this is the progress that we have seen with respect to technologies as it got then we have a machine learning, the few basic things. So I have added these things so that we can get a little bit of idea that what we are going to do. And so I think everybody knows over here that what is machine learning, what is AI, what is ML, and what is supervised, unsupervised. But yes, real life example is Netflix. So we are giving this the few recommendations to everybody. So everybody has their accounts, and everybody has given up these things. So it's an example. Then we have Google DeepMind, which is there. Then we have a few companies or few groups which are dealing with this machine learning a lot. And then we have now our generative AI topic has started over here. So if you will see, then we have seen that these are the biological neurons that are present in our human body, and generally we are doing the comparison with the this human neuron with respect to ANN or CNN. Typically, it's a correct one, but if we will say, then it's an incorrect one also. But yes, for this class, we will say that okay, this is the correct one because we have all the nodes which are interconnected one. But yes, the all the it's inspired from the all the algorithms are inspired from this biology. So we will see that all the this is inspired from the neuron, human neuron. And similarly, a neuron is connected with one other neurons. So we have all the cells, neural cells that are present in our brain, and through which the signal conduction will taken place, and information has to be stored. Similar kind of things we will see in our neural network, which is present over here. If we will talk about this thing, although it's RBM also, but yes, the each and every layer is connected with the one another layer. So we have input layer, then we have hidden layer also, then we have output layers also. Okay, so each and every layer is connected. Similar kind of things we will see over here, the neurons which is present in our human brain, and through which the uh, the nerve impulse, the signal has to be transported, and we will see that the reflex action that is happening in their body. So then we have an so this is a little bit of a connection with respect to deep learning or AI with the with our nature. So over here we it's 1943. So mathematical model inspired from the biological neuron. This one is there. Simple for single layer perceptron model, which is the single layer network. Over here we have seen this XOR problem also, which will rise over here because we are so not able to differentiate between two things. So that's why it's used the XOR. So we have input parameters, and we have weighted sum will be have calculated over here. weights are over there and the biasnesses which we are going to add, so that our all the input parameters will become same. And then we are going to add activation functions in order to introduce the non-linearity. Okay, so non-linear function, then we have a linear function also, so that it will classify the non-linearity in our data. So activation function that we are going to use over here, then we have a 1986. So then we have 1809. The CNN algorithm will develop over here. Then 1990, the RNN algorithm is there. But if we talk about CNN, so CNN is most powerful algorithm. So when it is introduced in 2010 by this Stanford University, so they have used, there is a one scientist Alex over there, Alex, I have forgotten the full name. So he has developed this thing, and then he has used this for the image classification purpose. So it's a powerful algorithm which will classify the whole things, and now it's used in almost every domain. So after 2010, this algorithm is used mostly widely in people are smart. People are start using this algorithm in a lot of domains, just ranging from agriculture, healthcare. So everybody is thinking about that how we can go to, if we have images, then everybody start thinking about how we are going to implement these algorithms. CNN is there, so we have input layer, then convolution will got perform over here, then we have pooling layer, then we have a FCC layer, fully connected layer, and we are getting the output in terms of data, input data which is provided to us, and then we are getting some output. So it's again a CNN. Then we have a recurrent neural network also. Hidden layers is there, input layer, similar kind of ANN. But the thing is, the main difference is that weights are getting updated. Okay, so let's say if we have more nodes, so if we are seeing over here, so update recurrent neural network, so it's getting updated each and every time. So there is a little bit of difference over here also. So that we will see early in this ANN, all the data will go in one directions, and then we have to feed forward network is not possible. But over here, all the weights are also getting self-updated. So weights are also self-updated. So if there is a correction, then it will recorrect itself. And then we have a scene that in 2006 again DBN network is there. Then we have a 2011, the one of the most one of the what we can say the non-linear activation function I developed, the ReLU. And when it will come, it is again exploded the whole things, because it introduced in the non-linear activation functions, and then exclude all the things, and it has reduced all the computation power of all the GPUs, CPUs which are running these machine learning algorithms. They have reduced this thing a lot. So just by using this ReLU activation function only, let's say we have 50,000 images, and then we have used, instead of ReLU, uh, let's say we are using sigmoid or softmax, we have used ReLU. So it will reduce your work computational task by 20 to 30 hours. If we are running this thing on a Google Colab system, or we have AWS system, or let's say we are working on our own workstations that we have over there. So just by using this only, we have reduced our computational power a lot, and simultaneously we are saving the electricity also, and we will contribute to a greener environment also. Just by just looking into the selecting the right activation functions, your work has to reduce a lot, and your resources has to reduce a lot. There is a one more activation function which is a Lekirilu, which will again use this. So just use good activation functions which will decide the properties of the data which we are going to do. So for that we need to do a good literature survey, and we need to find out which one will work best over there. And then we have a dropout, LXNet is there, then VGGNet will come, RCNN GenNet will come, and it's used a lot over here. Then in 2025 ResNet is there, then AlphaGo. So it's again a game which used billions of parameters, and it's used over there. And then it's used the reinforcement based learning, and so it's increased. So this slide will tell us the whole things about how the evolution, and the little bit of idea about how the advancement has been taken place. And then we have reached up to generative AI, and then we have large language model, and uh, this generative AI also. So this is very important ones. Then we have hidden layers also, same. Then we have a RBM. So if we see over here that we need a data and then it is getting traversed from one layer to another layer. There is a little bit of difference. So we need to understand those things as from the literature survey. So if there is some scholars over there, so they need to dig it out more information from the literature and which model will work best, that we need to figure it out. Now comes the generative AI. So generative AI, if we look into a definition of generative AI, so it's a set of artificial intelligence methodology that can produce the novel content. Novel content means the content which is available to us right now. We will feed those content, and then the new content has to be generated based on this previous content. So it's called as a generative AI based on the training data. So we have a textual data also, we have image data also, we have audio data also. So it will depend on our usage. So we have a audio data also available for us. So it will depend on our requirement and our expertise and in which domain we are working over there. So it's a input image data sets. It should be a input. It could be a textual, it should be a image, it should be audio, it should be a video, depending on our need. Then we have models that we are going to develop, AI generative models. Then we have a so this model will generate some of the images, and it comes under the form of AI artwork. So we have seen now this is getting revolutionized by the all the chat GPT and these algorithms which are there. So all the now we have seen most of the images are AI generated based images that we can see over here. And if there is, so this is a simple uh, line or simple workflow through which your model has to work. And then if there is something that we need to, then we have a post curation is there. Then if we need to do a tweaking, let's say we want to change some parameters, then we will do it over here, and then we will update this thing with the help of a pre-curation. So this is the steps. It will depend and it will change according to our need and according to our requirement also. And if you talk about, again, we have the huge architecture and pictorial diagram that we have. So what we have input parameters, then we are forming an image. So over here is a biomedical image, then we have this image is related with the biomedical. So we have this electronic healthcare records and in the form of signals. And then we have omics data also. Omics means related to the biology, so related to the human behavior. And then we are forming a graphs. That means that how the network has to be associated with one another. So it's related with the this image is related with the biology. So those who are dealing with the medical science healthcare, they will understand this thing very well. Otherwise, no issues. So then we need to do a literature survey, and then we need to form our publications, and then we have a clinical notes, and then we are going to form a knowledge graph. So this is a model that is developed by this particular paper. The link is available over here. You can get much more information from there. And then the interaction has to be taken place, the question answers. The question answer means we are making a generative AI models which will introduce the questions, and the patient is putting some questions and then it is giving some output. So this is the way. And then we have chatbots. So most of the chatbots now, if you will see all the banking system, all the healthcare systems, they are based on this chatbot. Then we have interactive note talking also, uh, the audio features that is present in our iOS, and then we have Android mobile systems through which we are talking to cell phone devices. Then we have Alexa, then we have a Siri. So all these are using this generative AI model kind of things to understand, but they are using some another technologies also related to the NLP also. So these things is interlinked with one another, and we need to come with the good models. Then we have this augmented process. So this is, will depend on the thing to thing, okay, application to application. Then we have radiology report. Then we have a text to protein generation. So this image contains all the example related to the healthcare, related to the biology. But we will dive into our own domains, so we can work accordingly. If we will do the literature survey, then we will find the few how the generative AI will be used in our domain. Then we have a few of the applications of generative AI. So we have a text generation is there, then we have a natural language processing is there, then we are dealing with the image generations, and manipulations. So a lot of images has to be generated, and a lot of manipulation has to be done in these images with the help of this artificial generative AI. Then video generation and deepfake creation, deepfake algorithm creations. So we have this seen a lot of fake videos are available on internet, and we have seen that this thing is a disruptive one also. We will look into the ethical concerns also, but this is a there are a few applications. And if you will natural language processing, how this thing has to work. So if we talk about the text generations, so if we are dealing with the text, generally will come under the category of natural language processing, because we need to process all the data and we need to understand all the text behind context that is available over there. So the software like ChatGPT, and we have seen other software also, we are providing some content in the form of a prompt, and they are analyzing this thing, and they are giving us the results. So in practical hands-on session we will learn this thing also, how this thing has to be worked. And then use cases include content generations, writing text articles, stories using natural language humor. Like, so now these days everybody is using these algorithms. ChatGPT, I think most of the person will be using, but yes, they are using the human like languages. So it's these are the algorithms which used to generate the content. There are Gemini there. So yes, everybody is using these technologies, and for this one. And then we have a language translation. So improving the language translation systems from one language to another one. So Hindi to English, English to so etc. There are a lot of translation algorithm is there. And then we have a chatbots, virtual assistant agent capable of having helpful, effective conversation with the humans, just like as your Alexa, just like as your Siri. So these are the most interactive chatbot. But yes, we have a few chatbots that are available in websites. Through we can get some virtual assistant also. They are giving us some replies. So on some behavior earlier, the thing was, let's say we are chatbot. So what I will do, if I want to figure it out whether the person is a human or not, 2 3 years back I just using this strategy also, because after 2 3 years back the humans are sitting at the back end and they are just giving the reply. So just give, so what I will do, I will just give them a random text. Okay, so if I want to know that is a chat bot or anything, they are giving some thank you, have a good day, thank you, I'm not understand. So we can figure it out by this thing. Now the research has to be done, and if you are giving these some content which is not a relevant one, they are going to understand this one also with the help of generative AI. So this is the way technology has advanced. Then we have text summarizations, the generating summarized a length of text. Let's say you want to create a paragraph or you want to do something, then it's use sentimental analysis to understand the classification and behavior. Then it's used in image generation and manipulations. Again, widely acceptable in generative AI technology like DALE, OpenAI allow. So it's a companies, OpenAI, which will be using this, the one of the most advanced company in the world. Okay, allow users to use the textual descriptions. Okay, so then we have image creation, then we have style transfer, so to another, and then we have a super resolution, also enhancing the super resolution quantity of our images. These are the few applications. Then we have some other application also, video generation, deepfake creations, and then we have a deepfake and manipulating existing videos, voice generation, music generations, synthesis of instrument sound, composing the melodies. Then we have a entire composition assistant of musicians. So it will assist, but yes, it will not replace the musicians. But yes, most of the work of music related has to be done with the help of generative AI. Then we have a game development also, data augmentation also, anomaly detections. So anomalies, lot of anomalies is there, abnormal behaviors we will find out um, in the systems, in the networks. So we are using this anomaly detection a lot. So generative AI has a huge applications. So if you want to do a research and if you want to do some task, then we need to figure it out our objectives, and within a couple of days, we can make models and we can run that particular model, and then we will come with a few uh, few papers, the good ones. So it takes some time also, but yes, we will work on these things. Then we have industrial use cases also, but I have put it in a separate sections, just because we are in academia, and we don't have access to that much of data. So there are few industry use cases also. Let's say if you are talking about retails, so we have a huge amount of data, but we don't have access to that one. So that is again a problem. Then we have consumer packaging records, goods. So if you talk about Amazon, Google, then they have resources, they have their all the data, they have their hands. So yes, it's used over there a lot, and they are using this generative AI a lot. Generative AI in manufacturing, and then we have banking, finance, telecom, then we have healthcare, then we have travel and hospitality. So it's a huge application, and we have a limited access to these resources, and we have a limited access to this data. If we will get, then yes, academia will also do this type of work, and then we will uh, do a better work also. So the getting a data again a challenging thing, and then we have another tasks also related to our data. But yes, so see, generative AI use cases: healthcare, then we have a content creation, NLP, art, music generation, text generation, algorithmic training. Then we have strategy, medical image synthesis, drug discovery, drug development, predictive marketing analysis, automated content, sentimental analysis, language processing, virtual assistant, chatbots, and high personalized medicine also. But yes, some amount of data is available in academia for the few of the websites. But yes, most of the data is not in our hand. So this is a bottleneck problem, and we need to find a solution for this thing also. So in the research, we can choose any topics, and then we can work generative AI. So just make one algorithms, and look for the different data sets and see how this will perform. Then we have how the generative AI will work. So generative will do, it's a type of again a machine learning that will look into the patterns. Pattern means kind of repetitive pattern that we have. And patterns, just like if we talk about sequences, if we talk about shopping behavior, if we talk about purchasing patterns, then we have some patterns. We are the human beings, and we have some type of way of talking, way of expressing the things, way of with the things, and we will this is called as pattern, and we need to look those patterns, and then we again the algorithm will look with this pattern, and then it is giving us the output. So it's a learning patterns, and a new content based those patterns. So it could be a text, it could be audio, it could be video, it could be code, it could be a generating new content. So pattern could be anything. It's the way of eating, also the way of working. So in advanced analytics, we can make some type of policy by just looking into the pattern of the particular person or particular human being. So generate a new content, then we are going to generate a new content, then we are going to do the training part also. To the training, then we are going to learning, then we are going to generate the content, and then we are going to the model which we are going to build up, it's going to give us the output. Then we have a how this thing work, how generative AI has to work. So what we will do, we will get data, and then we need to pre-process the data, and then the model which we are going to work, we are going to train this particular, and then we are going to identify the patterns. Yes, I think there is some disturbance. Okay, okay, no issues. So we are identifying the patterns, and then with the help of these patterns, we are generating the probabilistic the data generation and then iterate the training process, and then we are getting the feedbacks, and then this loop has to be repeated, and then we will, until unless we will reach up to the our desired results. So this is a few generative AI models, and the working of generative AI, artificial intelligence and machine learning algorithm is, first of all, we need a data, the good data that we have, which include the text, audio. Okay, then we need to, these are the steps. Okay, so we need to do the data pre-processings, which need the removal of outlier, removal of all the make the data, so that we can run our model best. Then we will do the cleaning, and then we will do the organizing the data into the proper manners, just like as if you will get medical image data, then it's used there. So first time when we get those data, first of all we need to do the data pre-processing and cleaning of the data. Sometime we will got some outlier also, some of the images which will not work in our models, so we need to eliminate those one also, otherwise they will hamper the accuracy of our machine learning model, and then our model get underfitted or overfitted also. So data suitable for training the models. Then we need to models, so we can use ANN, CNN, RNN, LSTM, GAN, whatever the algorithms which we want to do, based on the literature survey, literature, the what other has done, and we need to not go beyond that one also. Yes, we can little bit expert the things, but yes, let's say someone has work on SPM, we can't go to the decision trees because both have different ones. We need to figure it out which algorithm will work best on that type of data, and this could be done with the help of literature, and a lot of research work has to be done, and we need to figure it out those. Then we will learn the patterns and learn the structure and how this thing has to work. So it's a detailed data collection, pre-processing, training AI models, pattern structures, and then we are doing the probabilistic generation, and we will see the results. So this is the how the generative AI algorithm has work. All the, excuse me, all the algorithms that we have present over here will remain same. All the architecture will be same. Okay, data collection is almost same in CNN also, RNN also, in ML also. Then we have a data pre-processing is, so few of the steps will be remain same, but few of the steps will get changed, and with respect to that, the whole algorithm is changed, and the type of data which we have. So we need to look into that one. So it's the most crucial thing we are dealing up a machine learning model, that which type of algorithm we want to select, and this should be done. Again, the answer is the literature review, and we need to literature from World Wide Web, and then we need to implement those one, and then we need to results, learning pattern and structures. So we need to learn from the patterns, and we need to structures, and how we can find out the patterns. So to find out the pattern, the best thing is we need to look for replicates. Okay, the replicate patterns. So if we talk about healthcare, let's say we have some sequence, repetitive sequence, which is a repeated one, like ATTGCC pattern. And if there is a lot of replication is there, then we can say, okay, this is a replicated sequence, and we need to find it out. Take an example of, there is in biology it's called a data box. Take an example. So replication is, so we need a replication data also, where the things has to be started. So this is again a pattern. Then we need to structure found in the training data. We need to look for this particular pattern depending on the our need. Then we have to find out the correlations. Again, this is one of the important things. Why we are doing the correlations? Because let's say we have two entities, A and B is there. So how much percent degree of which they are identical to one? So how they are correlated one? So higher the correlations means probability that it's highly linked with one another. If there are two species which are highly correlated, that means they have same physical appearance, same, then we can figure it out that okay, A is equal to B if they are highly correlated. So that's why we will find out the correlations, and we have a statistical. So there are a lot of things that we are will do, but yes, correlations will be used over there. And then we have how the generative AI algorithm will work. So we have a input data, text, image, structure data, 3D signal data, and then with the help of this data, we are training our models. And our model has to be trained, and we will ask the questions. Okay, we will do sentiment analysis, we will do information extraction, we will do the image capturing, we will do the object recognition, we will do the instructions following, means for some kind of work where instruction has to be followed. So we will make that type of models, and we will get the output. So just so instructions, and then so this is the working methodology of a generative AI artwork, that how it has to work. And then we have a lot of discriminative uses of AI. Then we have generative use cases of AI. So how this has to be work, the generative AI, what are its uses and what we can do. So whether you want to this approach or whether you want to go with that approach, it will depend on us also. So there are discriminative use means it is you're going to classify the things just like as algorithm trading, which will stock will go up, which will go down, again a dynamic thing. Okay, so this is a discriminative use of generative AI. Then we have a dynamic price of the engines. Engine means some kind of commodity. Commodity means some type of machine, some type of machine or anything. Okay, then we have ad spend optimizations, the Google AdSense, how the ad has to be spent. So again it has to be changed, target again, location again, area. So there are a lot of parameters on which it will depend. Then we have a demand forecasting, means what type of demand is there in the particular market. Now there is a boom of computer science, so everybody is doing computer science, so it's a demand forecasting. Then we have a generative AI use cases. So what type of models that is used for a specific task. It's like as your chatbot for dedicated for neural science, just like as a your chatbot designed for the MRIs, for the detection of cancers. So we have specific things. Then we have a new material synthesized through the inverse of design. Then we have customer facing chatbots, specific things designed for the. So then we have a design and architectures, means for a specific tasks, just like as in architecture, in civil engineering, in physics. So this is cases of generative AI. So we need to figure it out over there also. And then again, applications, few applications. So it's used in almost every people have used. The researchers has used a lot of generative AI algorithms, image generations, manipulation, software coding, video creations, audio. Okay, so it's a uses in almost everything. Text generation, summarization. Then we have chatbot. Then we have enterprise speeches. The little bit of theory part is over. Now we will dive into the practical also, practical practice also. The models which are used for the generative AI purpose. So we have a variational autoencoders used to like image generations. Then we have image compressions. So let's say we have a data image compression or data compression also. We have some data, 10 GB of data or 100 GB of data. Now we need to compress those one. So we have certain algorithms, lossy algorithm, log loss algorithms also. But yes, with the help of these algorithms, we will compress that data and then we will be compressing that one. So again, tasks. So that could be done by these various variational autoencoders. Then we have learning the probabilistic mapping between input space and latent space. Then we have a GANs, generative adversarial network, used for producing the realistic images, the helicopter images. I will show you the few one also. Then we have videos, then we have other, then we have a consistent generator, discriminator, and then we complete in the training process. So gens are used over there. Then we have transformer based models for the language translation, text summarization, and chatbot development, just like as your ChatGPT. So if we are using this type of algorithm, it comes under the transformer based models. This model, and this model is used. This is a highly versatile model and it's used NLP and used for the text generation. Then we have autoencoders used for the data compressions and used for in the feature engineering. So let's say we want to compress things and we have images or we have audio data, visual data, we want to compress those one, then we will use the autoencoders, not CNN, not RNN, because this is used to predict the uh, or to generating the sequences. Let's say we have a few sequences and it's used mostly hidden Markov model is used a lot of in computational biology to predict the few things, few sequences, and we will make a hypothesis that this sequence would be deleted or due to evolutions this would be deleted or this would get updated or so a lot of things will be there. It's again a powerful algorithm, hidden Markov model HMM, and most widely used in sciences, mostly in computational biology. So yes, we need to use text speech synthesis. So yes, if someone is in this domain, then hidden Markov model will work best in this domain. Then we have RNNs, again generating sequences. Then we have text generation, music composition, time series predictions. Then we have DBN, and then we have LSTMs also, long short-term memories, which are used RNN. So it's again a RNN type. We will see that how it will work. And then we have convolutional neural network. Again, the world is super crazy with this algorithm. It has a thousand of paper, lakhs of paper will be published by these algorithms. Then we have conditional generative models. The model generates the specific conditions and it's used the GAN. For example, we can produce the images with the predefined characteristics. The conditional generative models. So this is the generative AI models that we are going to learn, and this is a few algorithms. And now comes the most important part of this particular topic in the theory perspective, that is dealing with the ethical concern of this generative AI. Although it's a very good technology, but the thing is that it has a lot of ethical concerns. Ethical concerns, just like as a spread of misinformation. So we have seen that a lot of fake images has been released in the in the market, in the internet, and then a lot of chaos is there, a lot of misinformation, spread of misinformation there, and to what we can say to divert the mindset of the peoples. If you will see, then the example is that in 2023 US President Joe Biden's it has done, although we can see in India also in few months back or few years, I think in 20 of our honorable Prime Minister Modi is there viral on the internet. So it has a huge, and then misinformation spread is there. So we need to tackle this thing and we need to develop some kind of solutions for this thing also, that how we can handle these kind of things. If we are dealing with this generative AI in a bad way, so it's again a blunder for us and it will create a lot of chaos for us. Then we have a artistic plagiarism, diffusion of deep dreams. So again, this is a questions that, let's say we are making one image, let's say Lena there, and it has some author which is owner of this thing, or this is a thing, then how we can use this thing? Okay, although we will take a consent also, but with the rise of technology, it's taking the entire web. If we talk about ChatGPT, they have downloaded the entire web, and more than 500 billion words they have used, and then they have built up the models. Again, this is a challenging thing for us. So artistic plagiarism, the concern of plagiarism and intellectual property right, what about those? So we need to make some solution in that domain also. We need to, government has to make some policies, we need to be much more aware about these things. Then what about license? The generative AI models which are generating some unexpected or diverse form of what we can say the images, hallucinated images. Although it seems good ones that how algorithm will do, but yes, it's again false informations. Let's say if we will modify some some girl face, make it a change with some hallucinated ones, then it's their loss and their, so we need to personal laws, and then we need to make much more awareness about these things also, that how we can prevent from this disruptive technology. Then we have biases and ethics. Again comes the things other. So all the, we need to follow all the ethics while doing this research, and we need to avoid this. Just like I take an example of this hate speech. So if you will see, let's say the person has done some hate speech, and uh, some AI model has to be generated, and with the help of this the video has to be related in the market, and it has a huge disadvantage. Take an example of polling campaign. So there is a polling campaign, and right now in the today evening, the lot of video has to be generated. 2 3 videos have to generated, or 10 videos, 15 videos, and they have circulated with lot of social media platform. WhatsApp, we have Telegram, we have a number of things. What about the innocent populations? Those who know, but if we are 140 crore of populations, and hardly 2 crore, 10 crore, 15 crores, no, 30 crore nodes, crores. But we need to educate those one, and we need to follow these ethics while dealing with this is the most important things also while dealing with the research work. Then we have privacy concerns also. Okay, so how we can take some image and we can generate some replicated AI sensitive information of private. Again, if you will see, Harvard review has in 2023, the Samsung employee has accidentally leaked confidential information to ChatGPT. So the prompt which we are giving to ChatGPT, it is stored over there, and based on it, the data has to be trained and the model has to be. So in this way, they are evolving the things. Again, a problematic thing for us. Let's say, so we earlier I have seen in the over here in the campuses also, a lot of the humanities faculties are here over here. They are using the ChatGPT for the random basis, and sometimes, let's say for the question creations, let's say we are building up some questions for follow all over India. So we are in the university. So so it's taking the example of the pan India. So again, a problematic thing. So if the model is there, and the model has to be refined, and it is iterated, and by the end we are going to get the questions, it's again a challenging thing. So we need to look while data into ChatGPT, or whether it is into the into some kind of things. All these, this is saved over there for their databases. What queries we have fired, what type of things which we are going to do. So again, we need to figure it out how we can come out with this disruptive things. It's a major challenge for the privacy. In we are not talking about this thing, but yes, in Europe, and they are much more advanced ones. But yes, our government is not doing these kind of things. But yes, we do make some awareness, and we need to be much more aware about these things and the concerns. So these are the few images we can recognize these things. Okay, although it's a little bit cute ones, but yes, again, a lot of things which we are dealing with. Again, then artistic images. So this is a very famous image of Lena, and now see what has to be done with this image. Although it's a code, AI code, but yes, it's available online, and yes, if someone will create my fake image and it is available in that sense, what type of use would be there? What type of impression will be there? So we need to think into that perspective also. Then again, these are the few beautiful images. Again, good. So then we need to figure it out these things. So it's a very beautiful image. So if you will see, so this is the positive perspective also, perspective also, we need to look into that one and then see what will happen. Okay, so this is the that we need to uh, look into the generative AI, and it's a little bit about theory part. Now I need to dive into the practical implementation also. So these things we will cover in the time of our practicals. They're related with the hyperparameters and this, because there are few jobs which will take half an hour also to run. So we will do these two slides at the time of practical implementations. Okay, so now I'm just going to the practical implementation of this uh, generative AI and its aspect of I'm sorry, in the real time scenarios. Just give me 1 minute, please. The concept of hyperparameters that we will cover over here. So if we will see, I need to stop this thing, and we'll share all the PPTs and all the collab notebooks along with the organizing team, and then we can make some changes accordingly, according to our need. So just few things. I have added less theory part, more of practical implementation. I will go within a speed so that we can cover most of the part. Although I think this is a recorded sessions, so you will get the most of the things. If there is some kind of confusion is there, then after the session is over, we will have a doubt session also. And I have got only 2 hours, which is a very less time to cover this particular topic. So I will try my best to complete, provide the most of the informations within this particular time period. So I will go in a little bit hurry. Yes, so first of all, what we need to do, we need to cover this particular topic. So this is the agenda. Okay, so we will 1, 2, 3, 3.14, and then there are two screenshot, and then one data set is also there. And I was creating this collab notebook also, but it will work, but it will not give us some output. It will work. So uh, yes, so first algorithms that we have developed. So now go into that part. So now I'm discussing the whole notebooks, which are just like the variational autoencoder, generative AI, transformer-based autoencoders. So we have collab sheets which are attached over there, and then we need to go. Okay. So autoencoders, I have added few theory part also. Okay, so that we can get some more information about that how this thing work and how we are getting the outputs. So autoencoder is one algorithms, variation autoencoders, which will the steps which are encoded over here. It's encoders which encode the things into the latent space. Space means just like as a converting one variable to another thing. Okay. Then there is a decompressions, which reconstruct the input images from the latent space distribution. So this is the output, and then there is a loss function which will add it over here. So if we have some idea of machine learning, then we have a loss function which will compute the distance between our actual value and our predicted values. And what with actual values, so if we talk about our machine learning, then gradient descent algorithm is there through which we are going to compute the loss function, which will be over used over here. And then we are using this mean square error. Then we have RMSC also, MSC is also there. So for take of simplicity, we are using the mean square error, and then we are regularize the things, and then we are getting to distributions. And what the encoder will do, we have these images, it got encoded and in the form of this matrix. the computation will get performed and we are getting the decoded value, and then we are getting the reconstructed image. Okay, so this is the simple idea. Let's say we will stuck into that type of problems where we have images and we are thinking, okay, we want to build up a autoencoder so that we generate a few reconstructed images. So in the type of problems we can use this particular thing, these particular algorithms. So what we need actually these are the all the standard libraries, and then this is a huge codes are there. Okay, so if I will go by this typing, then it will only one algorithm will cover. So I have limited times and I just want to deliver a maximum utilization of this particular time. So what I will do, I have created this all the things at first. So what we need to do, we need to import all the libraries, and 12 libraries are there. We have a TensorFlow is there, then we have NumPy for the numerical computations, because if you are dealing with the images, then images are composed of pixels, and if we want to perform any task, then we need to take those images in the form of array or in the form of some numerical values and computation. We need NumPy. Then we need a matplotlib to plot all the graphs, and we will plot with the help of this library, which is called as the matplotlib. Okay, so standard notation is there, similar like your header file in C++, in Java, whatever the standard things are there. Okay, so we need to import those one, uh, and it get imported ones depending on your internet speed. Depending on your internet speed and the things which we have. Then what we need to do, we need to define an encoders. What the encoder will do, it will encode the things. It will again depend on the problem. What we need a functions, and then we have make a layers, and then we need to call those functions. And this is the what we can say. This is a code which will tell us the all the function. So it will encode all the things, and then we are going to build up a data encode present over here. And now using the machine learning and AI based algorithm, so we need to add a few layers into that one also. Okay, so we are going to use some layers. So we are using the flatten layers. We have a dense layer also. We have flatten layer also. Okay, so there are a lot of layers when we are dealing with the CNN architecture. There are a lot of different type of layers. There are pooling layers are also there. So we are going to use these layers, and then we are going to use function is ReLU again. If you are using this Likirilu or this binary, then again we need to look for the computation resources which we have and what the literature is telling us. Okay, so we need to define. So for the simplicity and the most of the person will be using this ReLU, we will again make it up. Then we are going to compute a mean for it. So let's run it. Similarly, when this thing has to be happen, opposed to that, decoder will do. Okay, so it's got a reconstructed images. So we need to make a coder for this thing also. Okay, so we need to define a decoder. Again, we need some activation functions. We need uh, some input layers. This should be dense also. It should be the FCC layers, and then we are going to, over here we are going to use the sigmoid activation function because it's a simpler one, and it is giving us the value between 0 to 1. Okay, so if we talk about activation functions, then let me go over there. So if we talk about activation functions, so we have a lot of activation function are there. Okay, so sigmoid, so see, it's ranging from negative to 1. Okay? And this is the standard notation, the mathematical expressions of the sigmoid activation function, which is used over there. And then we have a non-linearity, non-linear activation function also there. So we have a linear, again binary, is 0 and 1. So values ranging from 0 and binary ranging from 1. So if we are using the binary, then let's say we are using classification model, then it's use 0 and 1 only. So why to use ReLU over there? We will use binary. Our work will be done with the help of, let's say we have two values only. So we will use binary activation function, and it's used over here. So linear, let's say our values are getting exponentials. Okay, it's linear. Values are getting increased, just like as our house price predictions models. Okay, and the exam fees to the student which are paying over here, the tuition fees again, it's a linearity. The it's getting increased almost every with respect to all the other parameters are there. But yes, inflation rate is also there, but yes, we can see this thing also. Then we have activation functions, so we can decide this thing that which will work over there. So ReLU is used over here, so it's again 0 and 1, so it will look for the max values only. Let's say we have all the images pixel that is present, and it is looking for the maximum values that is present to us, and the rest are become 0. So let's say we have a 512 cross 512 image. We are making a good models, and we have a very good computational resource also. So it, let's and we have 50,000 images also. Again, it's a huge humongous task to do a calculation for a CPU or a GPU. So it's a model get reduced. Then we have ReLU. Lucky ReLU will do the same, but it will look for the negative values also. We need to look for the this thing also. So it's a little bit of a difference between those one. So that's why we are going to use this thing over here, and the sigmoid is because we are dealing with the simpler things. We have only values which are dealing with the black and white. Okay, so it's a grayscale images. Then we are going to define the values of this encoders. Okay, so keras will be used, and we are defining the laws. Then we are going to what it will do. So this is the simpler things that our code will do. The define the we need to define our models, and then we are load our data. Could be any data. So I have used some standard MINIST data which we have over here, and a lot of work has to be done on this MINIST data. This one MINIST MINIST data set. So if we'll see, then it's available over here a lot. So it's a data so let's say we want to work upon some image task. Then this is a standard data set which will be used. Now, if you are doing a research, then replace this code with your own datasets. Okay, so some of the collab sheets I have some of the code is commented ones. If you want to do, then what you can do, just replace this particular line, this particular cell with your own data, which we have, and it should be used over there. So we will learn this thing also. This line. Okay, we need to replace this thing, and should be worked accordingly, and then we are getting the results. So let's load it, and we need to define an input space, what is the latent space, what is the input. So we need to study this particular algorithm first, what it will do and what is the output, and then accordingly we will give the values, and we will see how it will work. So let's say it is doing the coding, and then we are going to train the data again. These are the hyperparameters. Okay, so earlier in this PPT. Okay, so these are some of the parameters through which your model will work best or worst. Okay, so let's say we are working some data in the class that I will give some examples. Okay, so we will work on 70 students are there in the class. Okay, we will give 70 different results will be there based on these parameters. Okay, so so we will look for number of epochs, but it will do, it will backtrack all the things again and again, and then it will reduce our loss functions. So we will use 15s. Okay, it's used earlier, it was using 1000 10,000 also, but for this simplicity I have used it only 15 also. Okay, so this is the initial point. In another sheets we are using only one epochs only, so to demonstrate concepts over here. Then we have a batch sizes. Okay, so batch size of 128 or batch size of 32, batch of 64, or 512 depend on the, again it will depend on the requirement what we have over there, and it's used over there. So let's run it. I think I have to run this cell. We need to run this, and let's run it. Okay, and it will get run, and it is giving us some output. So ranging from epochs 1, and so till this thing will cover, and then we need to visualize. Okay, visualize the graphs or the data, whether our model has performed very well or not. So this is for the publication part only. So if you want to publish the results or you want to show something, then these are the libraries you use. Otherwise it's of no use, because we are building a models and we are going to deploy that particular model, then it will become good one. Otherwise we need to make papers, then that will work, and then what we need to do, we need to run those ones. So it is taking some times, and now after that now our model is getting trained. Okay, so what you can do when you get this collab sheet, run for 1500, run for 2000. Let's see. If you have a good workstations, if you hand on a good workstations, then you can use this thing and change these parameters. So batch size you can change, and then we will see the different results. Okay, so let's make it 15 only. Okay, so if we have a hands-on good workstation, good computational resource, which we have access to high performance computing facility, then you can make a very powerful models, and we can come with a good results also. So again, India is a developing country, and we have a scarcity of resources. So we need to, again, we need to figure out some of the solutions on this thing. So see 7, 8, 9, and then again this thing will work, and then we need to again new samples. So now again our model is looking for the new samples. So again we are going to define a functions and decode the values and the number of images. How many number of images we want to compute? I just want to images, and it should be the random ones, and then it will do, and the for loop which will iterate the things, and we have a grayscale images. So that's why we have used this softmax or sigmoid activation function over here. Otherwise we will use some also, because it's dealing with only two values. So let's run it, and let's see how this thing will work, and how the our encoder and decoder will okay, so it will give us some output, and then again explanation of the concepts. So sampling layer, what the sampling layer will do, custom layer to latent, and the encoders encode the thing, decoder decode the things, then training on the ministry data, and then again it's a 28 cross 28 image. So we have, imagine we have a 512 cross 512, or we have HD images. Now we can think of ChatGPT. They have what type of servers they have, what type of data centers, what type of resources they have. We are stuck in a 28 cross 28, and they are running the entire world. Results. Then we have training loss is there. Then we have reconstructed images. Okay, so I think they have come within 1 minute, and they will be there. Okay, then we are going to see the results. So loss is there. What type of loss? Again, we need to compute some of the graph for our publication purposes, and we need to reconstruct from the what it will from the original output, and the things which we have predicted. So then we are going to use the again matplotlib to visualizations, and we will see what would the training loss, what would be the validation loss, and then number of epochs, and then number of labels. So what you can do, you can add our own things also if you want. Let's say we want anything. Okay, so what you can do, just look for the parameters which you want to add in your graphs, and simultaneously we can add those things also. Okay, so again the task that we need to do, and we need to work upon, and then let's press it over there, and we will see, and again I will run all these codes. Okay, so again this is a reconstructing the image, and it's used for the graph. Okay, Same thing will be happened over here, and we are seeing the graphs. So show, and we are getting the results. Okay, so in this way we will see. So I have run this lab notebooks 2-3 times, and see, we are generating all the images, and we are getting the results. So within a minute, this work has to be done, and 1 second. I think that this cell has to be worked over. It will give us the output. Okay, so we will see the output. 15, 15, 15, 13. Okay, let's let's interrupt the executions, and and run on. Okay, so I will put it over there. These all the collab sheet will work. Okay, might be I've skipped some cell, and then it will get a update. Coming to our standard second generation adversarial network. So till we will, because all the collab notebooks, next we have a huge data sets also, so we need to work upon. Okay, so they are giving us some output. I think someone has raised some question. I will take your questions after this, because I will. Okay, don't worry. So this thing is there. Then we have a generative adversarial network. Okay, so how this thing has to work? Gen again. We have a discriminator, and then generative AI models, which will create all the images, and sampling images. We have that generate the plots between different images and different intervals. So again, we are going to use this ministry data, and we are going to perform this for our network, the model which we are going to build. Okay, so thing is that if installed TensorFlow for a matplotlib, because we want to install all the libraries. So I am using the Google Collab sheet, and it's used over there. So sometimes system, your computer will give some errors. Let's say you are working on workstations, and let's say the Python is not up to the version which we needed. So every time make this type of habits, that when we are making a machine learning models, what we need to do, we need to first of all use pip. So you can use this thing with the help of this terminal over here, that uh, that is present over here. Power PowerShell, or there is Jupyter notebooks is also there. So you can use with the help of this also, because Google Colab will, after 12 hours it get a reset. So again, we need to look. So if we have some less intensive, less data, then on Google Colab, rely on Google Colab also. Okay, so otherwise you can go for the paid version also. But yes, if you have a less jobs and some results, so we can rely on this thing also. So what we need to do, play will work, and then what we need to do, we need to generate the models. Okay, again parameters, again hyperparameters are there. Concept of hyperparameters comes to us. What would the number of epochs? What will be the network architecture? Again, this is the hyperparameters. So over here, the less time, because we need to, you can add own architectures. Okay, so literature work, and then we need to add layers depending on our need, depending on our environment, depending on our data size, depending on our what we want to do with that particular models. Okay, what are our expectations with that one type of computational resources which we, and so I have source right now, so I have used only this not layers dense, how much layer would be there, and Now over here we have seen alpha. Okay, alpha is again your learning, again your hyperparameter is there. Okay, so in this way what you need to do, we need to make this model which is using the generator, and then it's using discriminator also. It will give difference between different parameters which we have provided over there, and then that's the output. Okay, combine the generator and discriminator also. Again we need to change the parameters. And if my suggestion for all, for the research scholars, if you are sitting over here, then don't get confused, or things will take some times. So matters whether your model is taking 1 day to what 5 day to, but when your model is getting built up, then you can make a lot of good things over there. So be patient, work upon there on your skill set. Once the thing has to be worked, which very good results will come to us. So when we need to compile uh, all the training, all the uh, and then again generators, number of epochs, number of base size, number of intervals. Then we have ministry data is there, and it's used. We are going to add some of the noise that is it's dealing with image processing also. So we need to work upon, and then epochs we want. So this is the one collab sheet. The entire one we divide into the different sets. Then number of parameters, the parameter that we want in latent space, and then we have a compile and our models, and again parameters will come. What type of loss function are going to use? It's a binary cross control RMP or any type of we loss function are available over here. Again, it comes, we need to go with the, we need to study. Otherwise, uh, problematic thing for us. Then optimizer. Which type of optimizer we are going to use? Is the most used standard ones, but the thing is that we need to figure it out work best. Okay, so by default Adam is used. There are other parameters are also there, optimizers are also there, and too. So these are things. Machine learning, generally I have a student over there. The machine learning is we have 7 steps are there, 8 steps. Everybody has to do. But the thing is, the parameters on which your model is differently. So these parameters, all the utilization parameter, dropout rate, optimizer is there, what type of function we are going to use, and train and test split ratio. Okay, 80-20, 60-40, 90-10, again 50-50. So again depend on the our need about our data. Let's say we have 1 lakh of image of data, then we will go 60-40 also, we have no issue. No, no problem in that one. But let's say we 1,000 images, then if we are using this 50, so that's a problematic thing. We're using 80-20 again things. So we need to figure it out depending on things which will work and which will depend on parameters we need to work upon, and we need to look. So let's run, and we will see output, and some time to run, and we are going to run the, and we are getting the, it will take some time. uh, yes, so yes, our model is running, and now again we need to type also. Okay, float 32 int work over there. So again, small things, it will model heavy ones and heavy extension also. So again, mm, we need to look into these things. This cell is already running this one again, return generative AI, and we need to run for this and set for the parameters. See, we will get the output. How beautiful diagram is there. So it's constant one. increase, and after that it get a stagnant. Okay, after here, if you will see that it's seven, approximately 8. Now it's get a flattened one. Okay, now this is the threshold. After that, we will do anything in our network. Okay, we will do any type of hyperparameter changes. Whatever we will do, we will not see any type of increment in our accuracy. So this is the ROC curve, which plus that after there should be and values. Okay, no change there in our algorithms of changing all the parameters. Okay, but yes, we will see it's different. But and on again, we are going to use our model, whether it's economic model, whether it's a medical imaging. So figure it out. This thing also that severity of life is much more important than economic loss. We are working on a model which will work up uh, of cancerous is working on the prediction, what we can say this uh, on this loan prediction. Okay, so figure out that see an overfitted model that life is much more important than a person is get defaulted. Okay, so if our model is predicting, because we are not going to make a model through which on the model selection criteria we will 100 crore rupees of 1 crore rupees, 2 crore rupees loans instead of a life. This should be used for the smaller things, just like as if we are applying 5 lakh rupees, 10 lakh, 50,000, or 1 lakh. Okay, the small which are, so we are going to predict the so that we can reduce the task. But if applying for a 10 rupees loan, 1,500,000 is for, then machine learning model will not use the manually where there same things will happen over there. So the generative type of network we are going to use, and we will see that how it will work. So I need to just close this thing also, and all the graphs will be beautiful graphs will be created and to work upon will it, and our model is straight. We need to change. Okay, and your model will be if session with you for 3 days. Let it and see what type of performance it is giving us. If we are in, then buy some facilities, and then we get the good results. So I will, and coming to our algorithms, again, it's a uh, LSTM3. First of all, we will go into that LSTM3. Okay, term memory. Okay, so long short term memory will be a type of algorithm which will interlink and it will keep the way updated. So we will see that work. It is taking some time to get loaded. We will see output. Now error has to get, and so see we will get some of the results, the epoch span. The same model you need you need to do a little tweaking with respect to these codes, modify these code of our own work. We are going to do, and see we have a, although these are the results not good brighty ones, we will change the parameters, change the epochs, and our model for entire night for week. Yeah, we have a good, and we will run our model for a week. We'll see that it is the results. LSTM, long short-term memory. What let's say we will input some of the parameters which we will give. Okay, so it will look the predicted value, its sequence, and it will again word. So the is there, down is there, and street will be there. So ChatGPT will use little bit most of the higher version, but it give us some more one. Let's say we're working on some healthcare problem. This problem there we have a 50 cancer problem we have. We want to work on cancer only. There are more than 40 type of cancers. You know, then we have a lot of subdivision is there. So no, I would suggest we should go with the interdisciplinary approach, and it would be a good ones. Over here in we have find out that some of the students computer science. I'm talking, we have a protein structures. Then what is the use of this thing? We don't know. So again, we need to go with the interdisciplinary approach and tell the students need to work on the interdisciplinary. Go for the uh, humanities domain. Go for the geology. Let's say you are uh, working in different domain. Work in the farming domain also. Say we will explore the future and we will get a lot of good outputs. So we need to go with interdisciplinary approach and find out. And talk about LSTMs. So algorithm will work in that. Cat loves me, language will predict, okay, it will look, and then it will give some of the output, and then what it would be. Okay, so again, we are getting, and it's getting learned, and then it is again, cat loves milk, okay? MIL. Model will learn these things, and then it will give us the output. Okay, cat loves milk. Based on this behavior, MIL. So it will calculate all the percentage probability that what should be comes under after MIL. Mostly 100% it should be a milk, because cat is an animal which loves milk. So in this way, this LSTM models will work, and there is a lot of complication will be there. But yes, we are not going to do it. Again, we are going to import standard things which we have there. Now, I have taken some example of biology. Okay, so we have DNA molecules. Okay, so it should be your text, and it okay, so it should be your text, just like as a copy random text random chat, and you can paste it over here. Okay, and after that, what we need to convert into lower. Okay, for the simplicity. Okay, because otherwise we need to add a much more code, if else statement that we need to figure it out. We need to give some of the context, just like a DNA is always DNA, it should be written in over there also. But RNA is always RNA, it should be this is standard notations, so it should be like this only. Then we need to again we need to look for the indexes, and then we need to prepare our data sets. Okay, so what would be the maximum sequence length? It should be a disturbance. These parameters will come, and we need to change it accordingly. And then we need to change the again data type. Boolean type is there, then we have a length is there. Okay, so we need to get the output, and then we need to build up our RNN model. Again, T-layer model for this workshop only. What you can do, let me now, I have used for 500 epochs. You can use let's say for 50, I have less times. I need to cover it's also. So let's say 60, but a good model you need to use approximately 15,000. When I first time run this model, it should be 50% epochs. Okay, so loss function. So over here we will see our loss function is getting a decreased. Okay, so if we want to plot this, because we have used 50 only, let's this to let's change it to 100. Okay, so see now we have started our loss function from 3. Okay, 3.16. It is getting up to 1.75. Okay, so this is our loss functions, and it's between loss compute actual value and our predicted values. So actual is much more closer to our predicted value which we want to predict. we will get higher accuracy and we will see that, okay, we will reach our results. So we need to, hypothesis would be that we need to minimize the loss function. Okay, let's run it for the 100 epochs. You will see the results which will be available over here. Okay, and then we will get the uh, results. Okay, so see, receive 30 epochs only. Okay, so now if you will see, we are reducing the results, and then we are need to generate the text. Okay, because our model is getting predicted, and we get the results. Okay, so so see, we were getting the, and so this is the output which we have used for the 100. Let's see for 200 what would be the uh, output. Okay, so again, it's a LSTM based models, generated model. Again, earlier we have a textual data. Okay, we have only text. It could be anything. Now we are dealing with the music. Okay, that how we can provide music. Okay, let's say we are working on natural language processing, and we want to work on some specific problems related with dealing with the music generations. Okay, although it's again a challenging part, ethical concern, but yes, we will need to learn about the thing. Okay, so see, now we have a EMM, PNN, NT. Okay, so see, our model is getting refined, it is getting learned because we have supplied a less data only. That means we have run it for the 100 epochs, but let's say if we will get time and we will run this for 1500. Okay, and we have a very powerful system, and we will run it on a, we have a capacity of high performance computing, and we have a very good RAM, we have a very good GPUs, CPUs, and we have a very good labs, and we will run and make it a batch of 512. And over here, this, instead of providing one text only, we will give them entire library of 1 lakh books. Okay, so imagine, now we can analyze the context. Okay, so your model will work super fine, and it will give us the best outputs. So it will depend on the computational resources which we have, and then we have a, to see, now we are working on this image generation, not image, I'm sorry, about the music. Okay, so what we need to do, again we need to, so there is a standard library of music we need to convert. Again, we need to some understanding about what the node would be, what the code system. Okay, what is this saregamapa and this all sort of things. Okay, so these are all the nodes, and there is a MIDI data sets. Okay, music files which will contain, and what we need to do, we need to go over there to get the results. Okay, so these are the few nodes. Okay, saregama padanisa. So G1, C2. Okay, so we will get, we need to get some ideas, and then we need to convert these things into sequences. Okay, so length of sequences fit into the RNN. Okay, and we will get the results, and then again we need to run our standard loops, and then we need to get our results, and we will get the, assume that we are getting the 1,000 sequences uh, which we are learning, and then we need to fix this thing, and again we need to run this model. So I have sorted, so let's run it for 100 only. Okay, that side would be 32, and it is giving us the output. Okay, so this type of output we will see. Let's run, and it is getting the model is, now model is getting trained. Okay, now we are training the models. Now what we need to do, we need to provide the sequence. Okay, so model and seed dot length. Okay, so this code will look for the function to generate a new music sequence based on the model which we are going to train with the MIDI dataset. You can use your own dataset also. It has a huge applications. Okay, we can figure it out how the working speaking of our humans. Okay, so let's say we are working in our department, and we will record 100 200 voices of different persons, and then we will look into it, and then we will feed this network, and we will take some times, 15 days, 20 days, and make a models, and then it's used over there, and it is getting generated, and generate a new music. Okay, so now over here new music is generated, and we need to save our music. Okay, so last line, what it will do, it will save our music. So our music will get saved over there. Okay, so let's say it will now see generate music dot the music model seed sequence is equal to 100. Okay, so it will give us some of the sequences, and then it get generated, and it will present over there. Okay, uh, it will take some time. Okay, it is taking some time. So your music will look like that way. Okay, so where are we will over here, and uh, where yes, this one. Okay, let's take an example. This is a file. Okay, generated file. This one is a MIDI for file format. What you need to do, we need to convert this file format, and we need to go to music MID. uh, we need to go to, one second, just give me 1 minute please. Which type of extension it has? It's MID to MP3. Okay, MID to MP3 converter, because we don't have any conversion medium. So we need to go over here, and we need to choose from device, and we will go over here the down places, and let's run this thing, upload it over here. We need to, because why to convert, why we need a Python code for this thing, because we have only one image. But if we have, then we can create some separate block of code for Python, which will convert all the images into the MP3 or GPG, whatever we want to do. So MP4. Okay, so now what we will do, we will upload this, and so it is converting, and what we need to do, download this, and it get a downloaded one. Okay, so now let's say, now we will play this. uh, uh, yes, so yes, so now see, your our music is getting played. I don't know whether you are able to hear it or not, but yes, in my earbuds it's a simple piano based tune which is playing on over here, and we will see that how the music generation has to be done. Okay, so this is the thing, and it's a repetitive one. So after this workshop, when you get these all the collab sheets, I request go and run this, at least this set of code, this one. Everybody will get their hands dirty on this thing, and see the generation has to, how the epochs. So look for the 100, look for 100, run for 15,000, and you will see, now see our what we can say, this has generated over here. And now what we need to do, we need to download this, and I have earlier downloaded it. And now what we need to do, music 3, and what we need to do, we need to convert more this, and choose file, import from device, and we will uh, download music 3. uh, yes, yes, and go and convert this thing, and we will see the results. So it is getting converted. Now we need to download it, and see it's get downloaded, and generated 3. Okay, so now again it's a beautiful music that is played. Okay, now it is giving a different analogy for us. Okay, different nodes are now getting played. Okay, so I would request everybody who is present over here that by this sheet, everybody will run this LSTM3 text generator over here with this particular code, and see the creations, the creation that we have seen by the human beings or the codes. Earlier it was done by the musical instruments. Now the it should be done by this computer algorithms, and this all done by this computers. Okay, all the computational tasks, algorithms. This is our last collab sheet. Okay, if we will have time also, then we will go into that one also. This is related with the CNN superimposition. Okay, so I will take 5-6 minutes to go with that one, and then after that we will have a. Uh, I will open for your our doubts, and so if you will see CNN super resolutions. Okay, again it has a different applications. Okay, so it will depend on the needs where we are using this particular code, and we will getting the output. Okay, so again, let's say we have captured some image and we want to get some high resolutions. Okay, now mobile phones is doing, Photoshop is also doing, but let's imagine we have 1 lakh of images. Okay, 50,000 images, 10,000 images. How we will do this? Okay, again, we are not we are humans, and if you want to do this task 50,000 images, then might be it will take 1 year to do that particular task. Okay, so so we will do it within a day, within a 5 days, within a 6 days, within 7 days. So generally the good things will take some times, and we need to work upon over there, and we don't lose hope. So sometimes these things will happen when we are in the research, when we are dealing with a lot of things. Pressure will be there, but yes, we don't want to lose our hope, and things will work. And when we are performing our algorithms on a large data sets, then we will realize the importance of these things, that this is a what type of learning which we will get. So it's of just a mix of all kind of things, but when we the whole thing has to work, it will give us some pleasure also. So coding is just like as a maths or something, that it needs some expertise, and we need to work upon the problems, and we need to think upon. Sometimes they will work, they will not work. It will take some time. Okay, everybody has its own mental ability to learn the things. So if we talk about this uh, super regulations, okay, how the things will work. So we have SRCNN algorithm. Take an example. We have an image, and then with the help of convolutional neural network, it is getting over there. Okay, so we will getting the higher resolution of image which we have. Okay, let's say your camera has captured a low resolution image, or the experiment, or the MRI image, or the CT scan image, which will work over there, and we want the high resolution. We want to see the all the parts which are all the data that is present in our image. Then what type of task we will do over there? We have only super resolutions, CNN. And CNN is the most powerful algorithm which will do this thing. Okay, now our task is again standard. We are going to use this cipher 10 and cipher 100 data sets, and have accidentally typed it like this. Okay, so it should be cipher. Why it is not getting changed? Okay, so it's not a 0, it's cipher 10. Okay, one second. It's cipher 10 and cipher 100. Okay. Standard data sets. So the research work that so if some person is doing, then what you need to do, just change this according to our change the codes according to your need, according to your requirement, and we will get the results. Okay, what we need to do, we need to generative AI algorithm, convolutional neural network, the datasets which we have cipher 10, and then optimizations that we needed. Loss function is mean square error, MSC. Okay, again we need to compute which one will work. MSC is there, or MSC is better one. Then we have optimization, training, what we will do. Then we are dealing with the, so we are making this model. So this is a standard model. Okay, we can make our own model also. We need to pre-process training, testing, and what we need to do, we need to again, this is a standard practice, that when we are dealing with making a machine learning model, every time we need to, oops, okay, so we have make 2-3 sessions. again a limitation of this Google Colab. So we are yes, make it, and again we can't run after 2-3 sessions. So the solution is you can make another email ID and run it on Edge or another browser which we have, or it can work on the same browser also. Run a lot of model parallelly, make different email IDs, 5-6 email IDs, and run with the Google Colab and compare all the results with different within one day. This thing has to be done. So what we need to do, we need to import all the standard libraries. Now this thing has to be done with the help of PyTorch. Okay, so I have some 1-2 labs related with PyTorch also, because TensorFlow is used, but yes, PyTorch is also a library developed by the Facebook, and it's widely over there. Okay, so what we need to do, we need to import all the standard ones, and then again comes super resolutions. Shop only first layer, second layer, third layer. We can add 100 layers. Okay, depending on our need, depending on our requirement, depending on the type of work which we have. Okay, so second, third layers, 5, 10, 50, 20, 100, 200, 500, depend on our need, requirement, and then we need to run this thing. Okay, then we need to generate the low resolution image by the downscaling. Downscaling means, let's say we have a 128 cross 120 image, and we need to reduce it to 64 cross 64. So there is an image loss also, but yes, we will downscale this thing also, and then we will get the results. Okay, so it's a so this code, small code, will do this thing, and we will get the low resolution image. Let's say we have a very very what we can say this very high definition image for 4K images. We need to reduce this one, okay, because everybody can't handle this type of data. So these small codes will work over there, and we need to replicate this thing, and we will downsample all the image size within an hour, within 2 hours. So your computer things, and then you will get the results. Then what we need to do, now again we need to decide whether we have a CPU or GPU available. So if you have a very good GPU, or NVIDIA 2-3 parallel processing is going on over there, and it's parallelly connected, use a lot of GPUs also, and then otherwise you can use CPU also. So over here, this Google will offer us some GPUs also, GPU access also. So this thing will work. Otherwise, what we need to do, we need to just make it a comment. Okay. So with the help of Ash, it's getting commented over there. See, so our getting downloaded. Okay, so again learning rate is 0.01. Okay, what signifies this, that it will make the learning rate. Okay, so the concept of learning rate is this one. Okay, see, the learning rate, let's say alpha is too small. Okay, we will do a lot of, we want to remember these things, then it's a wastage of memory, and but let's say alpha is too large, then again it's a highly challenging task for us. We need to our model will not run each and every, and it will give us the wrong outputs. Okay, so this should be the appropriate one. The alpha rate should be the appropriate one. Again comes, what should be the appropriate rate for a model? So the answer is, we need to look for the literature, and we need to look for the data, and that we need to look for the resources which we have, and where our model has to be deployed, and what type of work it is going to do. The answer is, then we are going to train the epochs, and then we are getting the this, so it is going to convert. Okay, testing and visualization results, and now you will see. So over here, now this model will work. I will open up a few screenshots. So it's a so see, I have run this thing for 5 epochs only, and it will take. Okay, so for here session I've used for epochs only, and it is giving us the very good, beautiful results. So let me run it first, and let's say for how much epochs it is getting run. Okay, so it's running for 10 epochs. Okay, so after you will realize that it is giving us some good okay, and it is giving us some results. Okay, so this takes some
Excuse me, sir, your mic is on mute.
sorry. Okay, so yes, my suggestion is that at least when you get the sheets from the organizing committee, then you just run the sheets on your own system and make some significant changes, and then we will uh, make some changes and do whatever the sheets will do. Sometimes it will do magic for you. Might be you are able to publish one paper or two papers, might be. Yes, so that's all from my side now. Yes, so we will open for few questions if you have. Otherwise, this is from my side. Yes, I think. Yes, sir. Sir.
Sir, my question is first, you have used one latent space, distribution in latent space. What is
Yes.
that? What is the actual meaning?
Actually, this thing is used in auto encoders. Okay, so we need to do the literature survey, but I think it's used in auto encoders,
Yes, sir.
latent space.
Vari- Variation autoencoding.
Yes, so we need to look into that one. Okay. Yes, so basically in machine learnings, it's used for the image compression. Actually, we are working with a lot of different type of data which we have. Okay, so latent space. This if you are dealing with the image or if you are dealing with the compression part only, then we need to work upon. Just like as a there are a lot of dimensions which are available in our image, then it should be used for the inputting the data. So we need to do some literatures and then we need to find out a few things. Okay, but I'm not much more information about this thing, but yes, we have used these things, latent
Sir,
space.
what is the second question is what is the most basic difference between normal basic CNN and this super resolution CNN?
Okay,
Where is
okay.
the difference?
Yes. So what super resolution will do? Okay, so super resolution's image, if you will open up over here, the super resolution image enhance the pixels. Okay, so this is the this would be used in that type of scenario where we want to increase the just like as a picture intensity, and CNN is a basic algorithm, just like as a basic means and the algorithm which will do the classification, okay, just like as a male and female, just like as a benign or malignant is there. So these type of things, then we are going to use the CNN is used. I have written down, one of my student has written tomato disease classification with the help of CNN, her disease predictions, that my own paper that is dealing with this thing. So it's used, but super resolution means enhancement of the image, just like as a where are we? I think this collab sheet is still running, but if you will see, then it will giving us the enhanced image, just like as we have some image which is 128 cross 128, and it has some type of pixels, so it is increase the this thing. So this
No,
should be
sir.
good.
My question is, which are the layer that we are using that can enhance my image? What is the basic difference? Because that your normal CNN can't do that. How this is able to do in super resolution?
Super
Which are the
resolution,
layer that
but
any extra layer or something
yes, yes,
mathematical?
yes,
Yeah.
yes, I got your point. Okay, so what we need to do, we need to go into uh, okay, okay. So yes, so super resolution, what it will do. So see, we have this image. Okay, let's suppose this is a 128 cross 120 image, and 120 that side only, and 120 that side only. Now we will not able to visualize these things. Okay, so these are few pixels that are present. Let's super resolution, what it will do, it will enhance the pixel intensity. So instead of 128, it will become 150 or 156 depending on. So by adding few layers, it will enhance the quality of this image, so it get increased up little bit. Okay, we can depending on the layers, so we need to add a few layers, and then it will increase the all the layers. So CNN, what it will do, it will downsize and pooling, and then we have flattening layers, so it will look all the features. But when we add those features, it will give us the super resolution type of image, and then it's used over there. It's not still not running.
So in the what is the loss function in this MSc you are using?
Yes, yes, yes. MSc. This is for the demo purpose only. What we need to do, we need to just go with the learning part. Okay, we need to do the literature also. Okay, so we can use RMSC also, root mean square arrow also, which will be used over there also. So we need to figure it out which will work best. So
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 once you got the enhanced image, how you can measure that my image is enhanced, or what is the mechanism that we can measure from?
enhanced image. If you got an enhanced image, then it will.
Simply
Yes,
intensity increasing
yes,
doesn't
yes,
matter
yes.
like that. How I
We
can
need.
ensure that my image is enhanced? How I can? What are the mathematicals? Anything that I can say based on that I
Yes,
can.
yes, 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 yes. That is mathematically. See, we will see the enhancement in the picture quality, and we will see the intensity of pixels. So, if we our image is this one, that size, where are we? Okay, this one. In this PPT, mm, let me go with the over here, over here, over here. The pixel intensity is getting increased. Okay, so if the pixel intensity, so say this is a image. Okay, let's say, take an example of this image. So where is my pointer?
Sir, we are not able to see your screen actually. You have
Okay,
to share
okay.
it.
I think now it's visible.
No, sir, you have to share it. I think.
Okay, 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 I'm sorry. Okay, okay, okay. Hmm.
Sir, next speaker is also there. So,
Okay, 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 okay. So just give me 1 minute, please. Okay. See, we have this image. Okay, so this one is this one image. We have this image. Okay, this one, by just looking into this image, it will look like a face is there. Over here, it is giving us the much more clarity. When we are using this super resolutions, it is again the pixel intensity is getting increased, and we will we will see the outputs over here. So this is the way we are dealing with the super resolution images.
Okay. Okay.
Yes, yes. And now, if somebody has a more point, then I have presented my email over there also. You can discuss with the telephonically, no issues with that one. Okay, because we have a time constraint also. And thank you, Dr. Abhishek, sir, for providing me this opportunity. And thank you, sir. Thank you. Have a
Thank
good
you
day.
very much, sir.
Yes.
Dishika,
Everyone, please turn on your camera for the snapshots. Thank you, sir. Thank you so much.
Thank you, sir. Thank you, all the organizing team. Thank you. Have a good day.
thank you very much, sir.
Should I leave, sir? Or
Yes, sir. Stop sharing.
okay, 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 sir. Okay, sir. I just need to stop presenting and.
Ma'am, may we start the session? Good evening, ma'am.
Ma'am, your voice is not coming. Uh, Neetu, ma'am, your voice is not coming. Your voice is not coming. Neetu, ma'am.
Good evening, ma'am.
I'm audible now.
Yes, ma'am, you are audible. Good evening, ma'am.
Yes, sure.
Ma'am, may we start the session?
We can start the session.
Okay, ma'am.
Audible.
Hello, everyone. I am Dia Agarwal, going to host this session. It is my great pleasure to welcome you to the Faculty Development Program on Deep Learning Applications 2024. I take this opportunity to welcome our FTP speaker, Professor Neetu Mittal, and all the participants for this session. It gives me immense pleasure to introduce our speaker. Ladies and gentlemen, it is an honor to introduce Dr. Neetu Mittal, our Faculty Development Program speaker for the Deep Learning applications. Dr. Neetu holds a distinguished background with a PhD. She has 16 plus years of academic experience. She has published 75 research papers in international journals, including SCI indexed and conferences. She is reviewer of many journals such as Springer, IET, etc. She has delivered invited talks on artificial intelligence, pattern recognition, deep learning, and machine learning. We are privileged to have her with us today to share her knowledge and insights. Please join me in welcoming Dr. Neetu Mittal.
Thank you, Dia, for the lovely presentation, for the lovely introduction. So just confirm my slides are visible.
Yes,
Yes,
ma'am.
ma'am.
Thank you. I'm just putting it on the slideshow mode and then start. Okay. Now I am audible, visible,
Yes,
and
ma'am.
slides are also there, right?
Yes, ma'am.
Okay. So now, now my topic actually is related with some modern interpretability with some Grad-CAM techniques. So to move forward towards the Grad-CAM technique, first we need to understand about the model interpretability. As the name suggests, the model interpretability or the interpretability models actually uh, do the have the ability to understand the reasoning behind the predictions and decisions made by a machine learning models. So actually, why we need these type of interpretability models or why we want that, first we need to understand the reason behind all these things. So as artificial intelligence and machine learning nowadays have made their impact so much on the industries, now in education also. So the demand for transparency and accountability on these some intelligence systems have grown up now. So there are some complex models also, there are some simple models also. So while complex models can achieve remarkable predictive accuracy because of these uh, type of models, so their inner working open remain secret nowadays also. So it leaving users and stakeholders some questioning the reasoning behind their outputs. This challenge has given the rise to the field of model interpretability, because the working of behind all these models, machine learning models and CNN models, so the working behind all these models actually not so much open. So that is why to know about all these things and to know about the middle layers, to know about all these things, the interpretability or the models of interpretability comes actually in the picture. So their aim actually to shed light on the decision making processes of machine learning models, and it which empower the users uh, the trust on that model and understand those models. Ultimately it gives the power to these type of advanced technologies. So this is actually the reason for why this is actually the reason where and why the interpretability models exist or occurs. So in the era, because nowadays big data are there everywhere, and their algorithms, machine learnings, decision makings, CNNs, that become influencing the high stake decisions. So decisions actually need to be taken for the complex problems also. So like we can take the examples of healthcare. There's a life and death problems, and the doctors or the models need to be take care for for the patient's health and even the patient life. So these are some uh, sensitive issues and sensitive models. So they become now, and like finance problems, like criminal justice problems. So all these problems actually based on all these problems actually has been given the solution by these type of models. And for that, the model and the working of the model actually should be transparent, right? So everywhere the working of the model is like the black box. So to give a little to give a little light, to give a little shade on these the model interpretability models uh, gives the understanding, the reasoning and predictions and decision made by the machine learning models. So interpretability actually is the degree or uh, degree to which the machine learning algorithms can be understood by the humans. And these type of models have the ability to explain why and how a data science model works. Actually, the working of, as we discussed already, there are lots of models based on the problems like healthcare problems, criminal justice problem, like your finance problem, like your education problems. So these types of models and working of those type of models actually be known by the users are compulsory and necessary. So to make the certain predictions and what are the limitations and assumptions of these type of models, so user need to be take care all these things, and because of this the models need to be known. The interpretability of a model is a degree by which the human can consistently predict the model results. So we can say if we are talking about the all the models are black box, means having not known about the working of that, and these interpretability gives the uh, a shade, we can say the gray box. So these type of models or these type of interpretability techniques are having having the gray box techniques. So in which the users can see, users can predict, user can assume, user can put the limitations, and actually the limitations up to what extent the models has the limitations that can be known or that may be known by these type of models. And interpretability techniques helps to reveal how machine learning models can make the predictions. So interpretability of a model give the human having the known parameters, known criteria about the model. So by covering how various features contribute or not to be contribute sometimes to predictions, so these interpretability techniques can help to validate a machine learning and it is appropriate evidence for the predictions and find some biases in the model. There that were not the necessary actually during the training, or these are hidden during the training. So when we talk about the interpretability is the degree, so degree whenever the higher the interpretability, any type of machine learning model, in any type of machine learning model, suppose the interpretability is higher, so that makes easier is to the model predictions. So this degree, when we talk about the interpretability, model interpretability has some degree. So that degree should be at the higher end. Then only the model predictions or then only the model calculations or model assumptions can be known by the users. So higher the interpretability, easier the model prediction. So that always the degree of the models should be high. We can have the another method for this is the explainability also. So interpretability sometimes confused with explainability, because explainability is also this type of model means we are talking about explanation only. So the explanation of the model actually is not the interpretability of the model. Interpretability and explainability are different things. So explainability refers the explaining of the behavior of the machine learning model in the human terms, but without necessary understanding the model inner mechanism. As we have in the gray box, in the black box, so we have the specifications, but we don't know the inner circuit, but we don't know the inner criteria, but we don't know the inner mechanism, but we don't know the inner working of that particular system or particular circuit or the particular model. So explainability gives the explanation or it explains the behavior of the machine learning model, and especially in respect to the human terms. But the interpretability is not like that. Interpretability gives the glimpse of the inner model, inner parameters, but explainability can never give these type of glimpse, these type of parameters, these type of parameters, the knowledge of these type of parameters. And also the explainability can also be viewed as the model agnostic interpretability. Like for engineers, one approach to explain the behavior of the system is by using first principle. A first principle model has clear, explainable physical meaning, and its behavior can be parameterized. That type of model is known as the white box. Behavior of the machine learning is more hidden. So, if we say the degree, or if we say in the terms of the boxes, so yes, explainability machine learning models actually are the black box model, because it always gives the explanation of the model, but not the inner content or inner mechanism of the model. And interpretability machine learning models actually having some stuff, having some cuts of the inner material or inner mechanism. So that is actually the interpretable machine learning model, and that is why it is known as the gray box. But because everything is not known in this model also, interpretability, that is why it is not the white box. White box are some first principle models that has to be generated and that has to be designed by the users only. But interpretability models actually have the recommendations of the users, and these models are the put into the category of the gray box. So when we have the actually a model interpretability, when we say the model interpretability, so the approaches, what are the different approaches of model interpretability? The different approaches of model interpretability is the we can say the feature importance analysis. So in this, through this model actually, through these methods actually, the quantify the relative contribution of each input feature to the model's output, allowing user to understand which factor are driving the predictions. So feature analysis is the important part for any of the machine learning model, and the model interpretability actually gives the explanation, gives the mechanism, inner mechanism for the feature importance analysis, and it help feature importance analysis. It is helpful for the user to aware about which parameter is most important parameter for the prediction. Next, approach for model interpretability actually is the example based on explanations. So this is a different kind of approach. As the name suggests, the approach gives the examples, and on the basis of that, the explanation has been designed. So by presenting some meaningful examples, the this particular approach actually illustrate the logic behind a model decision, and these techniques provide intuitive and human understandable insights. That is the another approach. And very another approach, the third approach we can say is the visualization of learned representation. So first we have analyzed the features. In second approach, we have given some examples. Actually, the model has given some examples. And in the third one, the visualization of the learned representation. So whatever the representation is, the visualization of those type of representations has been presented in the third approach. So visualizing the internal methods, internal representations by the learned model, by the machine learning models or any kind of models, like the activation patterns in the, if we say the neural network, the activation pattern are the most important parameters on which the whole model has been based. So it can reveal the underlying features and concept that the model has extracted from the data. Next approach in this category, we have the counterfactual explanation. Now we have the examples also for the explanation. Now, next approach, we have the counterfactual explanation. So these explanation actually focuses on on describing how the model output would change if certain input features were modified. So this is actually the beauty of the interpretability. We can change, or we can assume, or we can make the assumptions of modifying the internal parameters, and we can predict the output of the based on that modifications also. Obviously, there are some challenges also for this approach. Okay, we'll discuss actually the challenges later on. First, we need to have the types of the interpretability. So, because interpretability is the criteria based on the internal mechanism, based on the identification, or based on the known internal parameters. So basis on those definition, basis on these definitions on the internal parameters, the interpretability methods have having two types, like the global methods and the local methods. As in the diagram, we can have the global and local scope of interpretability. So global methods are some methods which provide the overview of the most influential variable in the model based on input data or predict the output data. So that is globally. Globally means overall, not the internal, the overall data. So these interpretability method provide the overview. It gives the most influential variable in the model that based on the input, and it always predict the output for the global method, global interpretation. Now next is the local method. In local method, these type of interpretability methods in which the local methods are there, it provide an explanation of a single prediction result, right? Initially, in the global method, we have given some input and it predict the output simply. But in local method, as the name suggests, the local means the localized with someone or localized with the single prediction parameter. So it gives the explanation of the single prediction result. So in this figure, actually, we can have the differentiation between the global and local interpretability, and we can apply the interpretability in the groups within the data, and it arrive the conclusion at the group level only. Like a group of manufactured product were classified as the faulty. Which which group or which parameter gives the wrong or not correct output, or which gives the accurate output. So we can find it out through these interpretability models or these type of interpretability methods. There are lots of advantages of this model interpretability. Engineers and scientists having this model basically for the three reasons, like debugging, it provide the guidelines, it provide the regulations. Now, debugging, everyone knows about the debugging, understanding where and why the prediction goes wrong. So we already we have not got the correct or the desired output. Actually, not we cannot say the correct output, but we are not demanding actually that output. So we need to understand where and why our prediction goes wrong. So for interpretability, this is the main criteria or main parameter we have. Main uh, main advantage actually we have of the interpretability model, the debugging. It gives the super analysis where and why the prediction goes wrong. Running what if scenarios can improve the model robustness, and it eliminate the bias factors also. Now, next is the guidelines. So in the guidelines, black box and gray box model may violate the industry best practices. So if we have the gray box model, so then it gives actually little bit knowledge about the internal parameters, in which guidelines, in which regulations they have. It need to be understood. Now regulations, some government regulations sorry, require interpretability for sensitive applications like finance, public health, and transportation, but based on the government regulation. Based on the government regulations, because everywhere the rules and regulations are there, And if we talk about the sensitive data like the finance, like healthcare, and like transportation, like education, all these having this so much of sensitive data, so that must have some rules and regulations. So for these all advantages, because of all these advantages, the modern interpretability nowadays become famous among the scientists and the engineers also. Next, among these, we have some applications of model interpretability. So now the applications, interpretability tool help to understand why a machine model makes the predictions that it goes, right? So as the name is interpretability, so the it allow to give the knowledge to the user how and why a machine model can make a prediction. If any type of prediction has been made by the machine model, then this type of model interpretability gives the knowledge to the user why it gives that type of prediction. It's likely to become increasingly relevant as regulatory and professional bodies it continue to work towards a framework for certifying AI for the sensitive applications. In these applications like medical devices, like finance problems, and like any type of automated driving systems. So all these are the few applications actually we have taken, because these types of applications have some sensitive data with them. These are the sensitive applications. So that is why we have included only these 3 or 4 applications here. Otherwise, the list is too long for the applications. Also, the use of the modern interpretability in the different different fields, in the different environment, and in the different forms actually. And because these data are the sensitives, and these data are related to the person's uh, person's life and death, so that is why we have taken these type of sensitive application criteria as an example. Now, because we have model interpretability and we have so many different criterias and parameters to be known by the users. So for balancing interpretability and their performance, one device, or we can say one technique or tool, that is Grad-CAM, help bridge the gap between the accuracy and the interpretability. So Grad-CAM actually, it's a topic of this today's discussion, model interpretability or interpretability model through Grad-CAM. So Grad-CAM actually having the giving or makes a bridge between the accuracy and interpretability. So now, first, because GradCam is here, so then first we need to understand GradCam. So actually, GradCam is nothing. GradCam is the abbreviation of the gradient mechanism, or just give me a minute. GradCam slides are on GradCam. Can anybody confirm, please? My slides are moving.
Yes, ma'am.
Okay, thank you. So GradCam now, modern interpretability through GradCam. So GradCam actually is the abbreviation of the gradient weight, and CAM is for class activation mapping. So gradient weight class activation mapping is a technique which is invented by Selvaraju and their co-authors. And the main feature and the main parameter where in this technique is the gradient. So that uses the gradient of the classification score with respect to the convolution features. So as we have the CNN also, everybody knows the CNN and the neural networks. So in these type gradient are the main features. So gradient of the classification uh, score is used in this technique with respect to the convolution features. So GradCam is used to determine by the network in order to understand which part of the image are most important for the classification. Because every time we have an image, for the classification, obviously we have some image, and through this image, actually in this image lots of parameters are there, lots of parts are there. So which part is most important for the classification, that need to be determined by this Grad-CAM technique. Grad-CAM is a generalization of the class activation mapping system. Class activation mapping system actually is a technique, and it's a generalization form is the Grad-CAM. It also applies to the non-classification examples like regression and semantic segmentation. Actually, these type of techniques are used for the feature detection based on the segmentation, based on the regression policies. And the important thing is that actually these technique gives the awareness of the user which parameter or which part of that particular image gives the best classification. So it generates the visual explanations. It shed the line on the decision-making process to enhance the interpretability of the CNN-based models. Now, a GradCam is a technique for CNN. Now let's discuss about the examples of the GradCam, or discuss about the examples of these type of techniques like we are having GradCam. So GradCam, if we say the example is helpful to explore the semantic segmentations network by using GradCam. Now, it is a technique used in the field of computer vision. Basically, we can use it in the CNN and deep learning models based on CNN. So GradCam actually is the technique of CNN. It gives the explanation for CNN. It gives the visualization of the layering of the CNN, and we can predict the best parameter based on that visualization also when we want to update or when we want to change the parameter or upgrade the parameter for that particular classification. So that particular example show how to explore the predictions of pre-trained semantic network by using GradCam. Semantic network classify every pixels of the image that results into the image in an image segment by the classes. So different classes has been made based on the segmentations, and this in semantic networks, it classify the whole of the image based on pixel basis. So now it's the job of the GradCam to put the best classifier among those pixel areas, among those classifications. It need to find out the parameter, which parameter makes the best impact on the pixel for the classification process. So it can use the GradCam, a deep learning visualization technique, to see which region of the image are important for the pixel classification decision. So if we want to say, then obviously we can say the GradCam actually is the technique used in CNN or used in any of the deep learning model, especially in CNN, used in any deep learning model, which gives the best criteria, best classification parameter. On the basis of that, the pixel classification pixel classification decision has been made, which comes out the image into the segmentation and by class-wise segmentation. And it also addresses the challenge of interpretability in these complex models by highlighting the important region in an input image that contribute the network's prediction. So when we have the GradCam for when we have the GradCam actually for example, and we can use it as the complexity of to ease the complexity of the CNN. And GradCam serves a solution by offering visual explanation, which gives the understanding how CNN arrives at their prediction, for their predictions and through their predictions. because it's a new technique, good technique, but it is also having some problems. So few problems the Grad-CAM is having, like Grad-CAM fails to properly localize the object in an image if the image contain multiple occurrence of the same classes, right? Suppose same class object, for example, we can have the cars, different cars with the same class cars we have, same uh, visualized cars actually we have. So it 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 could not give the best result on those type of problems which is having the localized object in an image, and image contains multiple occurrence. And it's a serious issue as multiple occurrence of the same object in an image is a very common occurrence in a real world, right? Suppose everybody is having two eyes, everybody is having two eyes, one nose, two ears. So these type of same pictures we have, or everybody is having like the cars, same make cars we have, like Maruti cars we have. So it could not give the best result on those cases. Otherwise, Grad-CAM gives the best result in every field of life, in every field of problems. Now, because every time now grad cam we are discussing about. So now first we need to understand about the working of that grad cam, because it's the interpretability model. It's always help with the predictions and analysis. So grad cam algorithm can used to visualize the class activation maps of the CNN. So class activation map, that is the CAM technique, CAM technique we are having. So it gives the visualization of those uh, CAM maps of CNN, thereby allowing to verify the network is looking and activating at the current location. Suppose the current location, current pixel is there. So which parameter gives the best result on that particular location? Next parameter gives the best result on that particular location, that so on. So uh, these type of these type of allowing nature, or these type of verifications has been done, overall has been done through the Grad-CAM method. Now, deep learning models are often criticized by being having the black box algorithm that we have discussed earlier also. So, because deep learning and CNN models are always having the black box techniques, like we all know the black box technique, we don't have the super specifications for the specifications or super specialization for to understand about the techniques, the internal mechanism of the technique, the coding of that particular technique. So it's also always having face it always deep learning models always need to face the criticism that these techniques are the black box testing, we cannot change these techniques. So where we don't know about the internal organs, internal coding of that, so using a Grad-CAM, or we can have the using the gradient camera. So like Grad-CAM, suppose we have fit the gradient camera there. So deep learning practitioners can visualize CNN layers activation, heat cams, and like we can have the Keras and TensorFlow architectures we have, in which we can easily use the Grad-CAM techniques. And these techniques, TensorFlow and Keras, are actually made up for the Grad-CAM also. So visualization like this allow us to peek at the black box and ensuring the engineers do not fall prey to the urban legend. Unfortunately, the AI developer who created a cloud detector rather than the army desire of the tent detector. This is actually in all these problems, actually the Grad-CAM is working so well, where we need to understand what type of internal organizations it is, what if we change or modify one parameter, two parameter, what would happen after changing one or two parameters. So on the basis of that, the black box has been changed to the gray box. So whatever the criticism and whatever the limitations we have with the CNN models, and whatever the limitations we have with the deep learning models, that has been overcome by using the Grad-CAM or gradient camera architectures. Now, this is the overall working of the Grad-CAM pictures. sorry, Grad-CAM techniques. So here we are using the, here we have used the different layers. Now, through these layers, like we need to understand first of all. So here, first of all, we have the guided Grad-CAM. So this is the guided Grad-CAM. So this is the gradient we have. Now, first we have the guided backpropagation, and this is the input layer. And this input layer, actually, this is the cat picture, and this is lying on the ground. Now, this is the Grad-CAM. Through the Grad-CAM, we have taken the pixels, we have put the features, and based on this based on this picture, the features has been designed through the Grad-CAM. So this is the guided one, or we can say this is the machine learning method. The machine has been learned through this. This is guided back propagation method, and this is first input layer we have taken, and in through this the Grad-CAM. Now this input layer, the cat is lying on the table or ground. So this input layer gone to the CNN layer. Now here, rectified convolutional feature methods. So this is the convolutional different feature methods, and that has been segregated now. So this is the CNN layer. Now here the methods or the layers has been generated. Now through these layers, any task specific networks has been generated. Now this RNN or LSTM methods has been generated. The cat lying on the ground and image captioning. Image has been captioned as like that. Now and this specific task now then guided back propagation, and this is the guided back propagation, and here with these layers actually we are the backdrop till convolutional. So here back propagation till all the convolutional layers has been seen, all the convolutional layers has been guided. If we need to modify any parameter, or the user or the programmer need to modify any parameter, they can take the parameter and analyze those type of factors, and then go back with this. And here we have the different layers. So we can easily see these layers we can have. Now, specific cat like A, method A we have. This is a cat question. This is this, this is this. Now, image classification, we have classified the image. Here we can have the gradient, and here also the blue is the gradient, and this color is the backpropagation conventional method. Now, image classification. The image has been classified as the tiger cat. The image captioning is the cat lying on the ground. And here the visual question answer round is there is a cat question RSN yes, yes. So that actually answer the question if there is a cat, if there is a dog, because it always check about because machine through the machine learning all the images has been learned uh, based on the different methods. Now here, through the Grad-CAM or the feature extraction method, the question answers has been done, and the visual question answers has been done through the Grad-CAM method. So this is the overall diagram, overall picture of the Grad-CAM. So in this, we can say the Grad-CAM interpret actually CNN, and it revealing the insights into the predictions. So here in the different layers, we can say it always gives the prediction. It always gives the insight into the predictions, and it always having the debugging method. It is the advantage of Grad-CAM actually. So it always having the debugging methods, and that particular method always enhance the performance of the overall model. Now, class discriminating and localizing, it lacks the pixel space detail highlighting. So this is also the important parameter when we have the pixel area localizing method here. And we need to then use this method actually to learn or to modify the parameter based to learn the parameter based on the models that make more transparent, and then that make again more explainable to the to for the scientists and researchers. So it needs actually the Grad-CAM visualization is a technique. Now the visualizing and interpret the CNN decisions. So it always affect the CNN decisions, or it can modify through the layers or change the internal parameters. So it enabling the generation of the class activation maps to highlight the important regions of the images for model prediction. And it also explore the real world application, and it use the Grad-CAM that enhance the performance, or that enhance the result, or that enhance the decision making capability, that always enhance the decision making capabilities for the person, for the researchers, for the scientists, for the model developers. And it gives the CNN interpretability a new chapter or a new beat. It addresses the challenge of interpretability in these through these complex models by highlighting the important regions in an output in the image that contribute the network predictions. Next, we have the okay. So this is the working of the Grad-CAM historically. Now here the working of that particular diagram. So the it interprets the CNN model, it relieving the insights into predictions. It always gives the deep learning model to the visualization and understand the decision made on the CNN model. This technique actually disclose the hidden decisions by the CNN, and it transforms the totally looped model into the transparent one. It always decode. It means that we are talking about the Grad-CAM. So Grad-CAM always give the importance of each feature map. It always decode the all features to a specific class by analyzing gradient through the up to the last convolution layers. So it always gives mm, the we can also take a look among all the layers, and if we could have, or we the any other parameter could give the better result, we can modify that also. Now okay, Grad-CAM, this is also a simple diagram for the Grad-CAM. So Grad-CAM is required because it addresses the critical need for interpretability in deep learning model, providing a way to visualize and give the explanation how these models arrive at their predictions without sacrificing the accuracy. Now again, we have a small diagram here. So this diagram actually shows the prediction, the inner layers of prediction, the use of Grad-CAM, and finally we have some activation maps. So this first one, we have the CNN layer, CNN model actually, CNN convolutional neural network. Through convolutional neural network, some predictions has been done, right? So based on some predictions, because on the basis of some layering, the predictions has been done. So when the predictions has been done, the Grad-CAM comes. Grad-CAM see all the predictions. Grad-CAM analyze, actually not see, and Grad-CAM analyze all the predictions, and after analysis, it also map the analysis or the predictions with the different layers of CNN, and it gives the class activation map. Again, it required if any any other parameter with this model gives the better result, it can change, it can modify through the some activation maps also. So the modifications can be done for the betterment of the predictions, for the betterment of the decision makings, because these type of parameters or these type of predictions has been done uh, for the sensitive data informations, like in the healthcare. And healthcare always likes, we need to predict the tumor, we need to predict the cancer, we need to predict the life death, we need to predict the some serious disease. And if finances matters are there, so the exchange of money from one account to another account. So decisions could be on any type of system we can have. So all these type of sensitive data actually has been involved and include in these type of convolutional neural network prediction models. So on these prediction models, if all the prediction models are in the layer and we cannot see that model, so that model is not so efficient in as compared with the Grad-CAM model, in which we can see the layers, we can see the predictions, and even we can change the modifications. Even we can do the modifications, we can change the predictions based on the modifications, based on the parameter changing, and on the basis of that, the predictions are also being changed, obviously based on the class activation mapping system. Right. So when we say the class activation maps, so here we mean the heat map generations. We all know the heat map generations. So Grad-CAM generate the heat maps like class activation methods. Class activation methods, that is the upgradation of the class activation methods. In the class activation method maps, we can have the gradient weights also. So these map highlight the crucial region in an image responsible for specific prediction by CNN. So when we talk the gradient, so gradient analysis actually is also done by the uh, flowing into the final convolutional layer, focusing on how these gradient impact class, how these gradient makes the impact on the class prediction models, and it gives the visualization technique to the class discriminatory nature. Like other methods, it provides the visual uh, specifications for the particular predicted model and which enhance the interpretability. So now we have the, okay, now we actually comes to the conclusion, because interpretability, model interpretability, we have the model interpretability like the interpretation, or it gives the benefit visualization for the whole of the model. So it gives the machine learning the best approach, and it compasses the diverse array of the techniques like feature importance analysis, like we have some explanations with that, like we have the visualization of some learned representations, and in all these things actually Grad-CAM designed to enhance the interpretability model, enhance the interpretability model, basically especially for the CNN models we actually are talking about. So Grad-CAM generate the visual representations, visual explanations, and it gives the decision process up to the next level. When we say the in the conclusion, we can say the combining Grad-CAM visualization with existing high resolution visualization method, it guided the visualization process and gives the of superior interpretability for the betterment of all the decision making systems. And the last, we can say it gives the value. The Grad-CAM actually is the valuable tool for enhancing the interpretability of deep learning models, especially for the CNN models, which provide the visual representation for their decisions. When when we say it provides the visual representation of the decision, that means it gives the uh, balance, accuracy, also controlling power, also with these decisions, and through the visual representation, because every time the visual representations always having the great part for anything, and if it this visual representations are comes with the decisions, so that gives the best for the interpretations, for the decisions of any type of data, to analyze the data, to give the accurate data, to give the accurate result, and that gives the balance between the high performance and the best result or best output result. So that here comes to these are some examples, some machine learning models like regression, decision trees, and interpretability, and examples already we have discussed. The semantic segmentation is the best example for the uh, interpretability model, like using Grad-CAM. So thank you from my side. If anyone have any question, okay, can we have any question from anyone? Okay.
Ma'am, there is a question in chat.
Okay. Okay. From where I can access, sir? Sir, I'm not able to access the chat. From where I can access the chat questions?
In the chat, ma'am, there is a question by Pranjali. Pranjali, can
Okay.
you speak?
Sir, can from where I can access the chat?
Mm,
Actually, I think there is no option from my side. I can. Okay, find it. Find it. Got it, sir.
Yeah, ma'am. Can
Okay.
you please
So
switch?
Pranjal Joshi, can you please share the difference between the Grad-CAM and guided Grad-CAM? Okay. So actually, guided Grad-CAM is the when Grad-CAM is the simple method, right? So Grad-CAM is the method in which we can have the different layers we have. And guided Grad-CAM is the advance of the Grad-CAM, in which we can introduce the machine learning process. Actually, the scientist has introduced the machine learning process also, and one advancement process also, so that the always suppose we can take the example. Uh, suppose we have a bunch of cars, or suppose we have the similar face every time, and that type of problem has been arised, like in brain we have some tumor, right? A particular type of tumor. So the Grad-CAM has been guided now on the basis of that tumor and what type of tumor and these type of tumor. Whenever the tumor comes, the guided Grad-CAM always use the improved parameter for on the basis of that. Right. So this is the guided Grad-CAM, and simple Grad-CAM is the simple one in which we can find out the best parameter and we can have the prediction based on that particular parameter. Okay, and another one, some Markdeep Kumar have guided Grad-CAM demo, please. Yes, sir. Okay, so through with the Grad-CAM demo, actually, we can have the next session, because we need to have the next session for the Grad-CAM, because it's uh, always a code for that, and we can do the MATLAB. We can do the all the Grad-CAM in MATLAB also. So through the convolutional layer, first we need to identify, or first we need to learn the whole model, and then we need to find out the CNN, and then finally we need to change the one parameter from whole layers of the CNN, and then the Grad-CAM has been done with this. Okay. Okay, Abhishek sir, I have a session, one session also. So we need to
yes, ma'am. For the demo,
we need to continue or some break.
if you want to take a break, you can take, ma'am.
nahi, I just want to take a break for 2 minutes only.
Okay, ma'am, no issue.
So that is the session for the visualizing of features, right? Format.
Uh,
With
It's up to you, ma'am. If you want to
okay,
explain
fine,
this grad
fine.
cam, then you can explain it.
No problem, sir. Okay.
Okay.
Okay, I'm just going to share my screen here now with the MATLAB. Okay, that's allowed. Right. So for that, my topic is given to me actually is for identification of features and visualizing those features, right? So for that, first we need to open, and I'm doing all these things in MATLAB, right? So first we need to understand, I hope everybody is aware about that, but as it's my first class, so, and I mean, it's my first session. So first, just I want to give a small crux about the MATLAB and how we put all the images in MATLAB. And just give me a minute. I'm just doing things. So these two commands already, every time I have written these two commands in my script. So this is the MATLAB window. Abhishek sir, my slides are visible. My MATLAB screen is
Yes,
visible.
ma'am.
Okay, thank you, sir.
Yes, ma'am. Visible, ma'am.
Thank you, sir. Okay, so I again need to go to the MATLAB. So these two commands are, I always write to, that's my habit is I'm always writing these commands in my MATLAB, clear all and CLC. So first we need to understand the difference between both the commands, clear all and CLC. Clear all is called all the stuff we are having on the workspace on the command window wherever we have. So clear all, it clear everything, and CLC is for the clear screen, obviously. Everyone I think knows that. So now, because already we have 3 or 4 images here, jpeg, b.jpeg, brain.jpeg. Already I have having 2 or 3 images for the simplification. So there are 2 or 3 commands where there are 2 or 3 basic commands, because without these commands we cannot use the MATLAB, right? So 2 or 3 basic commands we have, like I am read, I am show. So first we need to write all these commands, then only we can use all the MATLAB things here in the, first of all, in this demo or in this session actually we need to identify how the features can be extracted from any of the image. So for these, we have very simple commands. These simple commands are understandable by everyone. So we need to first find it out the features from a particular image. Then we need to find out the features from some tumors, and then we need to find out the features or the tumorous part from the brain image, right? So this is actually the overall journey of our session. So now, because we need to first understand about the command, sorry, we need to first identify what type of commands actually we have to. So have every time we have to write these 2 or 3 commands with us. I am read, and my picture name is, we have brain image, brain dot jpeg. So we have written, put semicolon here, and I think now it has been done. Now this we need to make the show for that. So this is it. Now I think the brain image will appear in a moment. Okay, I need to write the command here. Fine. So this is the picture I have taken for the simplicity. And first we need to go through with the simple one, then little bit harder and little bit harder, then the last feature extraction part. So we need to understand the tumor part, or we need to identify that tumor part from whole of the brain area. Then we will go with the another feature extraction part, right? So now here we have I am show. We have taken the show for this picture. Now we need to find it out all the details of this. So for this we have who, whose. Whose for this? Whose for I. Right. Now whose for I. Okay, sorry. Run that. Whose for I here. So see at my command window, I can zoom it out. In the command window, whenever we have written here whose I is the variable where this picture has been saved. So now whose I, when we put whose I, the whole description of that particular picture has been given. Size, bytes, class, and attributes. Right? These are the very simple one, I know. Im hist is the command where we can find it out the historical histogram of these. Okay, done. Right. So this is the historical histogram of this particular diagram. Now, as we are talking about the changing of the modification of the parameters, so next parameter we need to change here is equal, and we need to change the parameter of I. Put semicolon here. Then we need to make the show for that. I am show for I2, I2, right? I2 show, A show I2. This is the present parameter. Is sorry, EQ, equalization. Right. So this is the histogram equalization after the histogram equalization, because every time we need the picture in some this manner. Now figure, and I am yes. Now we need to show the change of parameter which we were talked about in our description. I am his. For this picture, the histogram equalization parameter is this one. So earlier we have the scattered, earlier we have the blended histogram or the curves. Now through this, we have put all the curves equalized through this histogram equalization. So that is actually the example of the modification of the parameters. In histogram, we have modify. Every time the values are, see, just wait, I'm just giving the example. We need to understand that histogram equalization, right? So this is an earlier picture. If we remember that earlier picture have the one-sided and left-hand portions only having the bars, right? So this is the simple one. So this is the changing of parameter and adjustment of the images or adjustment of the contrast. Here we have. Now on this we have some, okay, just give me a minute. Here we have some on apps. Through this app we can go through, because MATLAB is a very powerful tool. If we know MATLAB, and if we know the tools of MATLAB and how to use the MATLAB, then MATLAB is a very powerful tool. We can do the we can do the programming in MATLAB, we can do the Python, we can do C, anything, everything we can do, and we can have the inbuilt boxes also in MATLAB. So now I am going to give the demo for the feature extraction, or we can say the segmenter in the MATLAB. So if we find it out the image segmenter, so in image segmenter, just give me a moment, it's loading. MATLAB is a bulky software, and all its division and all its just coming. Okay, so here, see, just give me. Okay, so this is our MATLAB screen again, and this is the image segmenter. And in this image segmenter, we need to upload the image from the file from the workspace. We don't have the file. We don't have, okay, we have the file on workspace. Okay, we can get it from there only. As I said, it's a bulky software, so we can get it from the file only. Load image from file. So we can have the brain image because we have to got the segmentation from this image. So this is the image, right? Now, this is the image and this is the tool. Image segmenter is the tool and this is the image. Now we need to identify that tumor portion because this tumor portion actually is known as the cancerous portion. So when we have this tumor portion, so doctors actually need to identify that tumor portion separately. So for this, we need to segment that tumor area from rest of the brain area. So here we have a lots of different things. I mean, lots of different parameters actually. On the basis of that, the segmentation or the differentiation actually has been done. So if we find out this, so when we put threshold, okay, it says the threshold can be performed only on the basis of the grayscale, and our image is the black, sorry, RGB image. Right. So now here we have applied the threshold value. When we apply the threshold value here, show binary. So here we can have the black and white image. Now we can apply the global threshold here and we can have the create mask. So here we can see the right. Give me a minute only. Image segmenter with brain. Okay. We need to go back. Back. Okay, close the morphology. Again, we have on the segmenter. Go with the threshold value. First, we need to change. Okay. First, we need to change the image into the binary one. We need to change the image into the binary one and go back again. Okay, include texture. Right. So here, see, we can have the threshold. We can change the threshold value. We can draw the region of interest also on the basis of that. So here we have suppose with this region we need to find it out. It gives the understanding of that part, right? So this is it for the inbuilt if we want to go with the inbuilt method, but I don't want to go with the inbuilt method because we want to apply the threshold value and we want to apply the features on that. So I need to go back. Give me a moment. This is MATLAB online. I have just opened the MATLAB online. Now, again, I am on MATLAB here. Fine. So I don't want to go with the inbuilt. I don't want to go with the default segmenter. Now I want my brain image, because I have seen that I have make the shown also. Now I have delete all the commands, but all the figures. I just want to need the my brain image. Just give me a moment. It's loading. Yes, it's loaded now. My brain image, and I want to put it on the. I want to do the segmentation, or I want to find it out the features on the basis of the commands. So we have the command for the okay. So this is the complete command we have for the. So here we have the brain image. Now I am read brain image. We have already did that. Fine. Fine. So the segmentation, अभी हमने देखा था, the threshold values cannot be applied on the we can apply, but threshold value is not easily applied on the colored images. So we need to change the image into RGB, into grayscale image. So this is the command RGB to gray. Then histogram, obviously we have to take in the histogram. Then we have to apply the filter for the betterment. And this is the filter. And then we have reduced the show. And then this is the segmentation process we have begin. Now, this is the threshold value. This is the main feature of this particular feature extraction part. So this value actually we can change. So this is actually that's it with what we are talking about in our previous session. So we can change the values in between. So this is actually the example, or this is actually the part of the Grad-CAM we can change, because it's not the CNN model, but yes, CNN model actually it's work like that. We have not taken here the CNN model because CNN model needs the machine learning process, and we don't have any much time to learn the machine for all these things. So we can change the value in between here also. First we go with this by default value. By default value is 230 for that particular portion, and then we can change the value. See, here we can have the C program also. As we have told you, we can write the MATLAB in C, in the Python in C++, in any of the language. So we have put the program, just need to change this threshold value to find it out the better output for that. So now here, just give me a minute. Okay. In this program, actually, we have given the threshold value. We have judged all the parameters based on that threshold value, and that threshold value is 230 here for that particular program. So this is built value. We can change the value also by our program. Now, threshold value, whole the program is based on the threshold value. Now see, here we have taken the entropy value here. We have taken the entropy value. Entropy value actually gives the information. Entropy value is the quantitative measurement or quantitative information about the picture. What kind of parameters, what kind of information actually the picture have. So here we run the program. Now see what happened. So earlier we have seen, you have seen the picture, right? So here we have some tumor portion here. I'm pointing out here. Here we have, earlier we have some tumor portion. Now here, no tumor portion and no brain image, but we have the tumor portion because we have focused that area with our threshold value. Now we were just talking about the change the threshold value. Okay. I'm just trying to change the threshold value. Now see what happened. Earlier the value is 230. Now we have taken 250 as a threshold value, as a random value. Now see what happened with the image. No, now no tumor portion is there. So that means by default, the perfect value we have. Now we can change the value somewhat lower to 10. Earlier we have 230, then 250. Now we have taken 210 as a threshold parameter. See, this is. So with this tumor portion, actually, we have some brain portions also. Actually, the doctor wants only tumor portion and a little bit of nerve areas, but no outline or no background the doctor wants. So earlier, when we have 230, that is the perfect. Now, when we can try with the 225 also. Now, this is, let's wait for this one. This one, I think is the better one for based on the three. 230 is the good one, but this is also the better one. We can have the best tumor portion here in 230 threshold value. So with this, we can change every time we can change. So on the basis of that, actually, the whole process of machine learning, the Grad-CAM, the interpretability model works. We can change the parameter, we can modify the parameter based on the user's problem, based on the difficulty, based on the sensitivity of that particular portion. So we can change the one or two parameters and machine learn about those parameters. Right? So now, okay, so when we have this, again, 230, we can run 30. If we allow it to run on 230, just wait for the result. So this is the 230 value. I think 225 is better than 230. I think 227 we can take. Okay. Just wait for the result. This is the better one. 227 actually is the better one. So we can have the 227, the value for the feature extraction. So this is the visualizing feature. This is the feature extraction for the tumor portion. Earlier, the image was the brain tumor image. I can show the earlier image also. You can have the look of this picture. And now I can put the comment on all the process and put run on that. And now we got the earlier picture, I think. Yes. So this is the tumor portion, the whole tumor portion we have. Now, if we give the uncomment of this picture, so this is the tumor portion. So this is the best feature or best program. We can have the feature extraction, visualizing the features, feature extraction process. So this is it for that. Now, this is we have done for the sensitive data, as we have the medical data is the sensitive data one. Next program or next identification or visual things we can have for some another picture with some another program. So okay, so first one, suppose we have some we are talking about the multiple not multiple, the various, if we have various pictures, if we have various objects in one picture, right? Then we need to identify these various objects, and we need to go through the outline of these various objects. Suppose we have some coins, suppose we have some circles in a one picture. So one circle should be identical and one circle should be differentiated from the another circle. So for that we need some boundary, right? So that is also the part of the feature extraction. So how can we extract the feature from one circle to another circle? In the image, if we have, suppose if we have 10 circles, if we have 20 circles, so every circle, actually the computer says every circle is not the differentiated circles. Every circle has one image, right? So we need to identify how much circles we have in our picture and what we need to give the outlines of all these circles, right? So this is the identification process. This is the identification feature process by which we need to do that. So for this, I have some command and I need to write one by one these commands. So first, suppose we have written any random image I have taken. So here we have taken some another image. So that is I am read, I am show RGB, because now this time the variable is RGB, right? Now see for the results. So this is some circles, or this is some coins, or this is some pieces of circles. we have here. Now we have to now identify, first of all, we need to count all these circles and then the circle on that particular boundary on that particular circles. Right. Now, what we need is draw line on that circle. So next command is draw line. Now the variable is changed. All the draw line has been stored in D. Now see what happened. So see, we can have the line, right? Give me a second for this. Okay. The gray image, show gray. Draw line. Now this RGB need to be changed into the grayscale because every time the image need to be changed into the grayscale, and then finally it would happen for the any processing, right? Now we need to identify the centers because we need to identify the pictures of the line. So now what these commands are helpful. So we need to identify the circle because this is a circular picture we have taken and we need to change this. We need to give the arc of that circle. So for this, we need to find it out the radius also. So this circle centers seems correctly positioned and their corresponding radius seems to match well to the actual chip. So one picture, I mean one chip or one circle have one circle and one radius. So for that means the identification of different type of circles or different type of pictures it is having. So for sensitivity data, we have taken 0.9. We can change it if we want. So see, these are some here centers and radius. So these centers, every center and radius has been, just give me a moment. Here we have these centers and these radius. So every center and radius have, like if we have 12 or 13 chips, so we have these specifications for centers and this is specifications for radius of each and every circle. Just put on the command there and we can change the sensitive area here. We already told you, right? And next, because of the limitation of time, I have already written the commands there with me. Right now we have already changed this image. Now again, because we have identified the centers and circles there, now we have changed this image into the again grayscale image. So now see what happened. First, because we need to identify the circle and radius, we have to change the whole image into the grayscale image. Now from grayscale image, we need to change the image into the red and white image, sorry, RGB image. And in RGB image, we have put the circles. See this. So now we 1, 2, 3, 4, 5, 6, 7. Only 7 circles or only 7 chips has been identified by this program. Now we put all the commands again to find it out the another remaining circles, and we have used one command, that is with circles, with circles. So that command actually means to identification of the circles with respect to the center and radius. Now see what again happened with this. Now length we need to identify because we need to find it out the next areas, because some areas has not been taken by the program. Now again we have put the program for these areas identification again. So now total chips are 16 and we have put the identification of all the programs. Right, again we have written some, just Give me a moment. Then again, for the first I write all the program and then I make you. So actually, this is the final output. First, you need to understand the final output. Actually, the final output is the feature extraction. So each and every circle has been extracted by the particular program and in the RGB image. And first, only we need to change that program with the image into the initial grayscale image. Now, understand the program line by line, not actually the line by line, because we all are uh, able to understand the MATLAB programs here. Here, this is, yes. So we have verified all the circles. So here RGB has been changed into, so what we did actually in the program. So in this program, first of all, we need to load the image. We have loaded the image. Whatever the image we have in the workspace or the name, just we need to load the image. Then in the program, we need to determine the radius and radius with the searching of the circles. Radius and centers and radius through centers and radius command and through IM find circles. We can find it out the circles from the whole of the circles. We need to find out the position of that circle and we need to give the underline outline for that particular circles. Then first, after that, with this program gray image, we need to change. We have changed this gray image into the RGB image. Then because the background is quite bright and most of the chips are on the darker shade, so by default, I am circle this one. IM circle finds circular objects that are brighter than the background. This one. So this line actually, this one, center radius, this one. So this line actually says that the whole circle always have the brighter image and the background actually is the lower one. So circle having the brighter one. So this I am find circle always point out with those circles and give the circular outline for those circles, right? And then sensitivity we have taken as a 0.9 sensitivity. So what does it mean? So now it's possible at the default sensitivity level, all the circles are lower than the internal threshold. So this is again with the threshold, we can easily change this sensitivity. But because in this sensitivity, it gives the best result, that is why we have taken 0.9 sensitivity. Again, we can change the sensitivity as the parameter, right? So now this by default sensitivity, which is in between the number, we can have 0.89 or it increase like 0.9, or we can try this sensitivity with different numbers. Actually, I have tried with different numbers and after tried all these sensitivity with all the numbers 0.85 or 0.9 or in between the values, we have find the best value for the feature extraction here. Now, again, we need to draw the circles. So for draw the circles, actually, we have here which circle, center and radius. So to draw the circles, we have the command which circle. So that circle centers seen correctly positioned at their corresponding radius seems to match well for the actual circle. Now, few circles actually were missing. Initially, few circles were missing. So we need to try all these circle again with the sensitivity of 0.9. Now here we have increased the sensitivity from 0.95, 0.9 to 0.92 or 0.95. Here we have taken 0.92 to increase the sensitivity. Right here, we have took 0.95. We can take 0.95 also. Right now, the length of the circle means it increase the sensitivity, finds even more circles, put the circles on that. And because delete H we have written here, delete previously drawn circles. Because every time when we need to draw the circles, we need to give a specific path, and that is why the delete H is necessary command for this one. Now again, we are using the another method to draw the circle. I am circle, and method we have written here. The methods is the second stage method or two-stage method we have already drawn here. So this actually looks the better result, and I am circle finds two different methods for finding the circles. And when so far the default methods we have taken, it calls a phase coding method. This one. And again, we need to change it into the grayscale. It needs the higher sensitivity. It levels to get the same number of the detections as the two-stage methods, like phase coding method also we have. Now find the brighter circle again. Center bright, through the center bright here. This one, center bright and radius bright. From here we can find it out the different circles, bright circles, and then bright circles, and then lower the value of edge hold, edge threshold, right? So here we have written for edge threshold, we have written 20 here, 20, 25, and 0.92 again we have written here. Here we have delete edge bright and edge bright, then finally we got the image. So this is the feature extraction method in the circles. Same method we can apply when we want to, because this is the circular, this code, all this method can be applied in the circular basis. We can change the sensitivity area, we can change the threshold value again in this also, and we can change any of the area, any of the value with this. And see if we have the, I think 16 circles are there. At the end here I can show you this, these are the values, this is the radius, and at the end it gives the result 16, because finally actually that we want how many circles we have in the picture. So ultimately it has been shown like the 16, right? Right. So this is the feature extraction or visualization of the features, or we can change the feature, we can change the parameter, we can change the threshold value also when we want to find out. So this is the X and Y. We can plot the graph also with this. These are the two methods which we want to show. Again, because nowadays the health or the health data is the most sensitive data. Give me a minute. Clear all and CLC. Now what happened with this clear all and CLC? It clears all the screen. Now again we are having the humor image, and I am just giving the little bit demo for this image. I just want to give the demo for the segmentation again. Brain image, brain dot I am sure of I. Okay, I have not put I there. I can put I is equal to brain. I am sure I remember. And demand, we have demanded the show for brain image, we have the brain image. Now through the app we can go with the Okay, we can have the we can have the image viewer. Okay, if we need to find out, just give me a minute. It's a last topic. Import the image from the file. Train image. Open. Okay, just give me a minute. Okay, yes. So this is an image, right? Now here we have, earlier we have the image segmenter, now we have the image viewer. So the image viewer, so just a technical glitch, I'm sorry. Okay, this is the image, and we can have the image overview. Okay, this is the image overview. If we want to find it out, the image metadata, so here we can have, so now see that. Now, because sometimes we need to have some pixel by pixel clarification, pixel by pixel awareness about the image, because every time it's a job of pixel. When we change the pixel, the image has been changed. When we change the pixel value, or we need to find it out on which pixel value we have to go the segmentation, for which pixel value we have to go the classification, for which pixel value we have to do the something. So for that we need the metadata, or we need the all the details of that particular picture. So here, through the image viewer, we can have the metadata, or we can have the all the details of the. This is the nearest picture. Now we have taken the byliner of this. We can export the picture also. We can measure the distance also. We can measure the area also. We can crop the image also. So MATLAB gives everything to you, and this is for the feature extractions, and for the viewing, and for the changing of the parameters, right? So I think I'm able to convey my codes, convey my um, I mean convey my everything, convey my segmentation process, convey my feature process to you all. And this is it from my side. We have taken the segmenter, we have taken the imager, or we have taken the viewer portion also. We have taken the feature extraction portion through some sensitive data, like the medical data, and through some circular data, or through some local data. And thank you so much. Um, okay, this is it from my side, Abhishek sir.
On the behalf of Faculty Development Program on Deep Learning Applications 2024 Organizing Committee, I thank the respected FTP speaker, Professor Neetu Mittal, for their valuable talk and hands-on the session. With the permission of FDP speaker, I am concluding the session. Thank you all.
I think one question has been written on the chat box. If anyone can allow, I can take the question. Instead of MATLAB, can we use Python for the same purpose? Yes, obviously we can use the Python. Actually, Python is the best programming nowadays, so we can use the Python programs for that. And the feature extractions and segmentation plays a very important role in Python programming. Sorry, Python programming plays very important role for segmentation and feature extractions. Thank you so much.
Thank you, ma'am. Thank you very much.
Any other
Yeah.
question? You have any other question? Thank you very much, ma'am.
Okay, thank you so much, sir, for calling me, for having me there in this platform. Thank you, sir.
Thank you. Thank you very much, ma'am.